Hello everyone. Welcome to KCD Bangalore. My name is Neelanjan, and I'm very glad to welcome you all today in this workshop. We will understand how chaos engineering can aid at assessing your application's resiliency and help you bolster its security as well. Also, we'll take a look at how harness chaos engineering can simplify your chaos engineering requirements with its extensive suite of chaos experiments and help you enable continuous resiliency for your applications. So before we get into the talk, I would like to briefly introduce myself. I'm a software engineer at Harness and have been previously working at Chaos Native. I'm also a maintainer of the CNCF Litmus Chaos project, a cloud native framework for performing scalable chaos engineering. In my day-to-day work, I'm responsible for assessing the resiliency requirements for any given application. So today we'll be discussing a few of these scenarios, which make up for a compelling outlook on an application's resilience requirements. Akash?
Thank you, Neelanjan. Hi, everyone. I am Akash Shrivastava, and I am also a software engineer at Harness. I've been a core contributor to the Litmus Kiosk CNCF project from 2021, and I've been promoting kiosk engineering all around the world so that we can have more resilient and better systems. I usually work on the core side of the Litmus Kiosk platform and the Harness Kiosk engineering platform with the addition of new experiments or new types of systems that we can inject here on. So yeah, looking forward to having a great session with you all guys. Thank you.
Thank you so much, Akash. So let's take a look at the agenda that we'll be covering today. We'll start off by understanding the dependency of digital services in the present day and the challenges posed due to the scale of its adoption. Then we'll understand the cloud native dilemma and how IT service downtimes can impact a company. Later, we'll take a look at how chaos engineering works and some of its best practices while also introducing harness chaos engineering in the same context. Finally, we'll kick off the workshop where we'll be doing a hands-on session on performing a chaos experiments on a demo e-commerce application called the online boutique application. And we'll be also be assigning sandbox Kubernetes cluster to each one of you so that all of us can perform the same chaos experiments in real time. So yeah, we have a packed agenda in front of us. Let's get started. And let us start by understanding the roots and origins of chaos engineering. Digital services are more relevant than ever before, and you can already imagine why. I mean, there are multitudes of reasons to attribute this. However, the most significant reasons include rapid adoption of internet services by masses, which is becoming increasingly cheap and accessible. Also, there are many other factors such as the COVID-19 pandemic that forced majority of the businesses to go online. On an average, we have about 4.95 billion internet users today who consume an overwhelming of 7 hours per day to consume these digital services. To tackle the overwhelming scale of operations required for hosting all of these users, mostly every business is choosing cloud computing to be their infrastructural backbone. And that's how the term cloud native has come to be. The applications that run and scale at a cloud native scale. Even legacy applications are choosing to be cloud native these days. However, how can we determine their resiliency now that they are cloud native? This question is relevant since applications are not that simple to operate. You have a multitude of microservices communicating to each other, each serving its own purpose. However, it takes only one of these services to go out and take out the entire application. With the challenges of debugging such an application is another topic that we'll be not really talking about here. The more relevant point here is businesses should be able to code reliably so that they're able to correctly assess their code in the cloud native environment. This is especially important for businesses who are pushing much larger code changes quite frequently. The culmination of all these issues is that, to quote the Murphy's Law, anything that can go wrong will go wrong. Or in other words, the complexity of the developments and operations will sooner or later catch up and cause failures into our system. But the question is, how can we be prepared for these failures to overcome them? Oops. So let us try to understand the issues we talked about in a better way. Our applications, now being cloud native, stand atop a plethora of other services that determine its functioning and resiliency. You have your application dependencies, then other cloud native services provisioning the underlying infrastructure, the Kubernetes services itself, and lastly, the platform on which your application is deployed. Failure in any one of these services can cause your entire application to not be able to cope up and crash. This problem is only accentuated as a more amount of code is now shipped more frequently at a weekly or even shorter cadence, which is expected to run in a multitude of different environments. The unpredictability of application behavior is the prime cause for service outages, since there is no way to know that how our application will behave when subjugated to an unanticipated situation. So just so that you guys can relate to a real life situation, imagine that we have an e-commerce application such as, to quote, let's say Amazon, and we know that there are frequent sales in Amazon, such as the Big Billion Days, for example, or something similar, Great Indian Sale. So what happens during these sales is that a plethora of users, too many users, try to access the same platform at the same time, and we don't know that how our application will scale under these turbulent conditions, whether our networking stack is good or not, whether our Kubernetes stack is working properly or not, whether all the microservices are meant to scale properly or not, or if the inter process communications or the communication between the microservices are able to go through properly or not. So this creates situation wherein you are more likely to run into service outages and your application not being able to cope up with the load. And that's the problem that we are trying to discuss and solve here. So let's try to analyze the impact of service downtimes on businesses. According to a report by Logic Monitor, companies with frequent service outages and service brownouts, that is degraded SLOs, experience 16 times higher operation costs, need twice as many team members, and take twice as much time to resolve the issues. So while these figures by themselves indicate the level of threat that service downtimes and service brownouts pose, they don't really cover the big picture. However, it should also be noted that 51% of these outages and 53% of these brownouts could have been avoided. So therefore, it's a good opportunity for us to take a step back and try to understand that what are the factors that are responsible for these issues. So now, I guess it's an opportune moment to talk about the big picture that we mentioned earlier. According to the 2021 Data Protection Survey report by VM, the average downtime for an outage was 79 minutes, with the cost of downtime averaging at $84,650. According to ITIC, in 2020, 1 in 4 enterprises that indicated a single hour of downtime can cost their firms anywhere from $1 million to over $5 million, exclusive of any legal fines and fees or penalties. The impact cannot be measured solely in cost per hour, therefore. There are many other potential downsides to outages as well. According to respondents of the same survey, there were 3 core impacts of the downtime. That includes external impact, including the loss of customer confidence and damage to the reputation of the brand. Internal impacts such as the employee morale and diversion of resources. And lastly, the litigation and regulations, which can have a significant effect on the company valuation. So the need of the hour is to mitigate, if not totally eliminate, the predicament of downtimes. What organizations need to acknowledge is that it's not a question of if, but when will their organization will be affected due to one such downtime. While one can prepare for these issues in prior, no one can fully anticipate an overwhelming downtime before it actually takes place, since there are a plethora of ways in which things can go wrong. So with the entire applications now changing their underlying infrastructures at the pace of hours and minutes for the much needed competitive edge, the question is, how can they always withstand the chaos of adverse situations? By breaking them on purpose with chaos engineering. Chaos engineering is the way to go for all those enterprises who want to prioritize resiliency and reduce downtimes for their customers. It is about adopting a culture of building resilience against unforeseen challenges with their systems. So, how does one make a system resilient against something unanticipated? By understanding the system behavior under turbulent conditions, which are representative of the real world failure scenarios. Therefore, the key to successfully practice chaos engineering is to understand the complexity involved in your system through realistic experiments and hypothetical conditions. Only by fully understanding the pros and cons of your system will you be able to choose the right kind of measures for your system. However, we need to understand the difference between deliberately harming our systems and doing chaos engineering. We can't just stress our systems to break and phrase it as chaos engineering, right? Rather, we should create reasonable real life circumstances that might affect an application's behavior. So that gives us an opportunity to understand the application in a better life. So the question is, how to do chaos engineering efficiently? Well, what we learned here is that, well, first thing you need diverse chaos experiments so that you can exactly replicate the chaos scenario that you're trying to recreate. Secondly, you need to use real world failure scenarios and not just some synthetic failure conditions that are not representative of the real world conditions. So let us try to see a few more. As far as the general best practices are concerned, chaos engineering is a culture oriented approach. It finds its place as part of the DevOps practices, and hence developers and SREs should work together for best efforts. While developers should run chaos experiments from an early stage in the development and slowly scale their tests so that all different kinds of chaos scenarios are covered, SREs, on the other hand, should focus on how to make chaos engineering practices scalable to run into CI CD pipelines, as well as execute the seed tests within the staging and eventually in the production environment as well. It's paramount to have a robust set of chaos experiments that can cover all the different types of failures that might potentially affect the application. Lastly, you need good observability to assess the impact of the chaos throughout the system, and hence your chaos engineering tool should provide with enough insights that can help you understand if the application is indeed deviating from its steady state in an unanticipated manner. So these are only a few requirements of what a good chaos engineering practice looks like. As you must have understood right now, it's something like a DevOps where it's a culture rather than it's something like a tool. So how can you implement a great chaos engineering practice within your organization? Well, Litmus Chaos can help you get started. Litmus is a tool set to do cloud native chaos engineering. It helps both developers and SREs to automate the chaos experiments at different stages within the DevOps pipeline, like development, during CI CD, in production, and so on. Fixing the weaknesses leads to increased resiliency of the system and your application. Litmus adopts a Kubernetes native approach to define the chaos intent in a declarative manner via custom resources, that is, Kubernetes custom resources. It uses the operator pattern and relies on the custom resource definition, that is, CRDs, to define the experiments. On top of that, Litmus Chaos provides a UI called the Litmus Chaos Center dashboard, where one can orchestrate and visualize the results and metrics of the conducted chaos experiments. It also features the Litmus API for programmatically injecting and managing the chaos, features for teaming and collaboration, GitOps management for chaos, and Chaos Hub as an open source marketplace for the chaos experiments. So it's also worth mentioning that Litmus Chaos has seen tremendous growth and adoption in major enterprises dealing in all kinds of technologies, further validating the need of chaos engineering and its versatile applications in all kinds of technical domains. So while Litmus Chaos continues to be a versatile and open source project for teams who want to explore and, most importantly, extend its tried and tested capabilities, here at Harness, we have perfected it by adding a myriad of enterprise features to create Harness Chaos Engineering, a robust chaos engineering framework for all the resilient first applications. So you can imagine harness chaos engineering as a superset of Litmus Chaos, which includes every feature that Litmus Chaos offers and more. So what are these features? Harness chaos engineering borrows the same concepts of scalable cloud native chaos engineering upon which Litmus Chaos stands and extends its application while still retaining the open code design. As we'll see in a while, it's really simple to get started with harness chaos engineering. And if you have used Litmus Chaos before, the experience is pretty much the same, except that you've got around 100 faults to play with, spanning across not only Kubernetes, but also AWS, Azure, VMware, GCP, and Linux. It also boasts of improved integration with all the popular CI/CD tools out there, including native integration with harness modules, most notably CD. And HC also simplifies this observability during chaos via its real-time experiment logs and streamlined application dashboards. So it's really as simple as signing up on the harness platform, choosing your appropriate fault based on the blast radius that you want to experiment with, and then running your experiments while monitoring the impact on your application. And while you are creating these experiments and gaining confidence with them, you can then finally enable continuous resiliency for your applications with CI/CD integration of chaos. So yeah, that brings us to the end of the presentation. And we will be now starting with the more interesting hands-on stuff where we'll be doing some real life chaos using the sandbox environment clusters that we have. But yeah, before we go into that, I would like to open the floor for any questions. Please feel free to ask any questions.
Hey Neelanjan, there was a question in chat from Abhi.
Sure.
What is a brownout?
Okay, so service brownouts refer to, wait a second. I guess I mentioned it in this slide, right? Was it this slide? Okay. So basically,
Mute yourself. Sorry.
Yeah, so service brownouts basically refer to it's like service outages only, but in service brownouts, the accessibility to the service is really hampered. So wait a second. Let me try to give a better analogy here. Okay, so as I was saying, service brownouts refer to nothing but the ability to affect the SLOs in your application. It refers to how your application experience degrades. And the idea is to somehow measure it in terms of some quantifiable metrics. So, for example, if we say about SLOs or service level objectives, we have degraded SLOs with us. And degraded SLOs basically translate to some kind of outage scenario or some kind of lack of service that you had already promised. So degraded SLOs and SLAs kind of contribute to service brownouts, if that makes sense.
So what is the difference you mentioned, the litmus chaos and harness chaos? I didn't understood the difference. Is it a different product or is it?
All right. So Litmus Chaos is nothing but an open source chaos engineering framework that is within CNCF. It's adopted by CNCF and it's an incubating project under CNCF right now. If you know, I mean, CNCF is also maintaining the Kubernetes. While Harness Chaos Engineering is an enterprise chaos engineering framework by Harness. And of course, it extends on the open core principles of Litmus Chaos. So it uses the same open core framework that the Litmus Kiosk provide. However, it builds more features and enterprise offerings on top of that, including all the benefits of, let's say, improved number of faults that you get, or for example, the observability that you get, or the logs are, for example, in real time, so on and so forth. It also integrates pretty well with the other harness modules such as the harness CD and so on. And of course, it has better integration, not integration really, but you can also target more number of chaos infrastructures using harness chaos engineering. That is, you're not just limited to Kubernetes. You can also target, let's say, Linux, or a plethora of cloud platforms using harness chaos engineering. So that's kind of the difference.
Thanks.
Sure. All right. Do we have any more questions?
So with this Litmus only, we can only integrate with the Kubernetes only, or it is also allowed with other Linux or other cloud platforms?
All right. So essentially, you can also target Linux or any other cloud platform using Litmus Chaos. However, it more depends on where you want to actually execute these experiments. I mean, there is something known as the execution plane in Litmus. Similar to Kubernetes, you can think that there is a control plane of the Litmus and there is an execution plane of the Litmus. The execution plane refers to the place where your experiments are literally running or executing. So here in Litmus Chaos, you are only limited to a Kubernetes execution plane. That is, you would need a Kubernetes cluster in order to execute your experiment per se. However, with harness chaos engineering, you can extend your execution plane to not only Kubernetes but natively Linux as well, and therefore perform much more scalable and native Linux experiments with better integration, better observability, and so on. So the overall experience, also from the developer side as well as from the user side, improves with harness chaos engineering.
Okay.
Hey, Neelanjan, is it similar to Chaos Monkey kind of tool? It was there, right? Which was developed by Netflix, I guess. Is it similar to that, or?
Precisely, Sajid. So Chaos Monkey was first of its kind. Actually, it was the, you can say, first chaos engineering tool that was developed by Netflix. A brief intro, like a brief history of Netflix. So as you all know, Netflix started as a cloud first companies. They had all these EC2s and all this cloud infrastructure running on AWS. So they needed a way to correctly assess their services. They needed a way to understand the impact of service downtimes on their platform. So for that only, they had invented chaos engineering as a means of assessing the resiliency of the Netflix platform. It kind of grew on from there, and it has right now become a practice. So not only these big and large and giant players who are operating in the cloud space, but it's very much also required for uh, all these other enterprise applications that are also running in cloud or even in your own data centers or otherwise. It's basically just a resiliency practice right now that enables more resilient applications. All right, do we have any more questions? Awesome. Okay, so I guess we are good to go with the next leg of our workshop. What we are going to do now is we are going to the real workshop. And before we actually get into it, let me give a brief of what we are going to do today. It's going to be a completely hands-on workshop. All of you will be having an opportunity to request for a sandbox cluster. I'll show you how to obtain your own sandbox cluster. And as part of that sandbox cluster, you'll be getting an e-commerce application along with a Grafana dashboard, a Prometheus data source, as well as a kubeconfig file for accessing that cluster. So if you are not familiar with, excuse me, was that a question? Girish, was that a question? All right. As I was saying, we'll be having this sandbox cluster with us, inside which you'll be getting a demo e-commerce application known as the online boutique application. Along with that, you'll be also be having a Prometheus data source, as well as the Grafana dashboard. And you'll be also be getting a kubeconfig file so that you can access this sandbox cluster. So if you're not familiar with Kubernetes, don't worry. I'll be showing you how you can get started with it. And I'll be also showing you that how you can sign up for the Harness Chaos Engineering platform and get started with Harness Chaos Engineering, right from how to sign up, to connect your first chaos infrastructure, to running the experiments. So yeah, we can actually get started. If you guys are not able to follow through any step, please let us know in the chat. While I'm showing you the steps, Akash will be helping you with the exact steps that you need to follow. If there is any, help that you need, please let us know. All right. So with that, let us start with the workshop. Just a second. Let's share my screen. All right. So I'm just sharing in the chat a workshop guide. This is the workshop guide that we'll be doing. So let me just go back to Zoom. All right. Please open this link in your browser. You will be able to access it. And once you are able to access this link, we are going to actually all start together with the steps that are mentioned here. So first thing is, of course, this is a workshop on Harness Chaos Engineering. We'll be doing the sign up on the Harness SaaS platform. We'll be seeing that how we can get started with the Harness Chaos Engineering in particular. Since if you're not familiar with the Harness platform, it's an umbrella of tools that the Harness is providing for better developer experience. You have Harness CI, Harness CD, Harness STO, Harness CCM, and including that Chaos is also there. So yeah, that's what we are going to do. And next we are going to obtain a sandbox environment to run the Chaos experiment. I'll show you that how you can fill up this Google form in order to obtain a sandbox cluster that you can use for the duration of this workshop. After that, once we receive that sandbox cluster, we'll be setting up our chaos infrastructure. So we'll be understanding what chaos infrastructure is and why do you need to connect it, as well as how you can connect it. Lastly, we'll be also be connecting a custom chaos hub. A custom chaos hub will be helping us to get started with the experiments that we'll be performing today on our demo application, as well as monitoring the application. So, and then of course we have 4 experiments before us, which we'll be performing. So in due time, we'll know that how are these experiments going to help us. But yeah, enough said. If everyone is started, if everyone is ready, let us get started for the workshop. So yeah, assuming that we all are here, the first step is to log in into the Harness platform, or rather sign up for the Harness platform. So for that, just head over to this link for the Harness SaaS platform. It's app.harness.io. So you will be presented with such a link, but since we are not signed up yet, we need to go here at sign up and please ensure that you are only signing up with your email. This step is important because we will be mapping your email accounts with the sandbox cluster request that you will be providing via this form. So please make sure that you are only signing up with an email. So I'll be just providing my email over here. And secondly, my password. So of course, you will be getting a verification email into your email account. So let me just open my email account as well. And similar to this, you will be also getting a email here to verify your own email address. So just simply select on verify email. Upon the successful verification of the email, you'll be taken into the Harness platform. And here you have a comprehensive view of all the tools that Harness provides under its umbrella. You have CD and GitOps, you have continuous integration, CI, cloud cost management, feature flags, service reliability management, and lastly, chaos engineering. So let us actually take a look at chaos engineering by getting started here. So as soon as you're getting started with the chaos engineering, you will be presented to the screen where it says to enable chaos infrastructure in your to run your first chaos experiment. However, we are not yet ready to do this since, well, we don't even have an application or a chaos infrastructure to get started with. So how do we get started with that? Well, if we go to the workshop guide next, we will be seeing that the next step is to obtain a sandbox environment to run the chaos experiments. So the way to do this is, as you will see that we have a form link appended to this workshop guide for your help. I'm also just copying this link and sharing it here. Actually, let me just copy it from here. All right, so I have also shared this form link with you in the Zoom chat. Just make sure in this form, while you're filling it up, you are providing your email as you had used while signing up for the Harness platform. You are supposed to use the same email that you had used for signing up with the Harness platform. As well as you need to provide your Harness account ID so that you can obtain here. I mean, when you come at app.harness.io in this tab, you will see that you have this URL wherein it says -ng/account/ this is your account ID. So you just need to copy this account ID in place of the in place of this Harness account ID. So let me fill it up with my own details for your reference. I'll just fill up my first name and my last name and my organization and the email. So the email is what I had used for creating my Harness account. And lastly, my account ID, which is this. I'm just copying my own account ID. All right. So once the request has been sent, you should be getting a new sandbox cluster within around 5 to 10 minutes. So we would have to wait for a while. So while I am doing this, please feel free to also put in your request. And if you're not able to do so, if you're not able to, let's say, access the form, or if you're not getting back the sandbox application, please let us know. You can just ping in the chat if you're not able to, get back the request for the sandbox cluster, or if there is any problem. All right, guys. So are you able to get through the form? Let me see a show of hands who have actually successfully submitted the form? Okay, Krishna Rao says he has submitted the form. Others, please get going with the submission of the form. Without this, you won't be getting the sandbox environment. All right. As you guys can see, I have already received my access to the sandbox environment. So you will be also be receiving a similar email. But let us all wait until we all receive our sandbox environments. So just let us know if you're not getting any email. Just let us know if you're not able to submit the form. All right. Maybe we'll give it another 2 minutes for everyone to submit their forms, and hopefully you will also receive your own sandbox environments. After that, we'll be getting started with how to use these sandbox environments. May I know in the chat that who all have actually sent the request for this form? Please write something, I mean, in the chat, let's say sent or something, if you have actually sent the form. Awesome, awesome. Sent and received the email. That is also awesome. Okay, Abhishek, just wait for a while. Hopefully you'll be also be receiving very soon. Awesome, Anuj. All right, Anuj, so we'll be understanding in the course of the workshop that how we are going to use these monitoring tools. Actually, they have been already set up. We don't need to set them up as part of the sandbox cluster URL that you have received. So yeah, I mean, whoever has actually received the email, feel free to go through those URLs that have been shared with you. We'll be discussing in detail that what they exactly do, but yeah, feel free to play along. Meanwhile, let us wait for the one last minute for everyone to receive their email so that we can get going. Akash, can we create a poll over here to understand that how many of us have actually received the sandbox cluster environment?
I think the host only has access to create a poll.
I see.
Put the
Vandana, can
meet
you?
link.
Yeah, sure. Thanks, Shashank. Please create a poll so that all of us are on the same page.
All right. So I don't have permission to launch a poll. There are only a couple of questions that are allowed, which I can't customize.
Oh, all right, not a problem. Suresh, what is it that you want to be shared to you? Suresh, you need to fill up the form that, all right, let me just share back the link of the form so that you can fill it up. Okay, I don't think this is the right link. Just a second. Wait a second, Suresh. Let me just share you the form details. All right, for the benefit of those who have joined late, let me just again explain that how you are supposed to use this form. Once you are actually opening the form, you are supposed to fill in the name, your first name, your last name, and your organization, as well as you need to first of all sign up using your email in the Harness platform, that is app.harness.io, and use the same email in this form to set up your sandbox environment. Also, you need to copy your account ID into the form. Your account ID is here, that is in the URL of app.harness.io. You will find your account ID appended after the account route. All right, Suresh? Awesome. Yeah, no worries. Thanks. So just make sure that you're using the same email that you use for signing up into the Harness platform, as well as copy your account ID into the form and submit it. You shall be getting your sandbox environment very soon. All right. Awesome. I guess we can get started if the majority of us have received this sandbox environment. I'll pace through a bit slowly, maybe, so that everyone catches up, even if they have not received the sandbox environment yet. But hopefully, all of you will be receiving it very quickly. So, yeah, assuming that you have already received this email, what does it say? Well, it says that please find the attachment to the Chaos Sandbox environment for the namespace Neelanjan-Manna-NS. So that is my name suffixed by -ns. So for you, it will be your first name dash your last name dash ns. That is the namespace of the Kubernetes sandbox cluster that you will be accessing. So to be precise, you will be having access to a namespace within a Kubernetes cluster only. You will be able to access all the resources that you are creating or that are already present in that Kubernetes cluster. So please try to make good use of these resources. Please be judgmental of how you are investing in these resources and use it for the purposes of this workshop only. Also, you can see that you have the URLs of these three applications. First is the boutique website, that is the website that on which we'll be performing our chaos experiments today. So let us try to actually open it. As you can see, the boutique website is an e-commerce application with a similar interface to all the e-commerce applications out there. There are several things that you can buy, and you can basically access all of these products. You can go to the particular product page, you can add them to the cart, and so on. So it's a pretty similar experience that you get into all these e-commerce applications these days. So this application will be our base reference application for today's demo. What else do we have? We have this Grafana dashboard as well. And this Grafana dashboard is deriving from this Prometheus metric server. This Prometheus metric server is the data source that contains all the relevant application monitoring metrics for our online boutique application. So if you are willing, you can definitely go ahead and check the Prometheus metric server. However, we are visualizing the same information by means of this Grafana dashboard. So in order to enter our Grafana dashboard, the default email and password are admin and admin. So that's admin for the username and admin for the password. Let us try to log in. We can skip for the new password creation. And upon logging in, we can go to this menu toggle and try to access the dashboards. Upon accessing the dashboards, we have this general folder which we can expand to find the boutique app dashboard. The boutique app dashboard. So if we access the boutique app dashboard, we'll be having a bird's eye view of everything that is going on within our cluster or within our application. So the important thing to keep in mind is that this is your personalized Grafana dashboard. This is your personalized application metric endpoint. I mean, for each one of you, this application has been deployed and same Grafana dashboards have been created. So whatever chaos experiments that you will be doing today will be on your particular application, and therefore you will be able to personally monitor your chaos experiments and see how your chaos experiments are affecting the resiliency of your application. So observability, of course, being one of the pillars of chaos engineering, is paramount to understand the impact of chaos experiments, because without observability, chaos engineering is just chaos. You won't be able to make sense of anything that is happening to your application unless you have observability. So on the similar note here, we have this Grafana dashboard that on the top determines the probe success percentage. That is what is the availability of our application. It says that that success percentage is 100 right now. That is, the probe is fully the application is fully available right now. There is no latency or no outage in the application, and essentially the application is working correctly. We also have front-end QPS, that is queries per second. That is how many queries we can make to the front end at this time. So it's somewhere between 100 and 150 QPS right now. So that is a healthy metric. Also, the access duration of the front-end service is also low. As you can see, it's pretty marginally low, near the 22 millisecond, which indicates normal system behavior. If we look at the other metrics as well, they are not deviating that much. I mean, it's between how much, let's say 75 to 50 QPS. I mean, that's a healthy metric right now. With application usage, this might fluctuate a bit, and that is fine. This is not a big deal. It's only a problem if this number falls below a certain line, and if the access duration is increasing, that is the latency between these microservices is increasing. So in a similar fashion, you can see that we have lots of different microservice dashboards over here. I mean, lots of different microservices. But wait, where are these microservices even located? I mean, these microservices that we are witnessing over here, how can we see their deployment in practice? So that's where our kubeconfig file comes handy. Just go ahead and download that file. And upon downloading it, what you are going to do next is try to access your terminal. And through this terminal, we'll be actually be seeing the Kubernetes resources. Assuming that, okay, so Krishna Rao has a question. What is QPS? QPS is queries per second. Queries per second simply means that how many queries that are made per second are actually getting received by the application and being responded to. So that is a metric by which we are measuring the responsiveness of the application and therefore determining whether it's healthy or not, if that answers your question. So yeah, moving back to the terminal, what we are going to do right now is try to access the application deployment of our demo microservice. And we'll be seeing the actual application microservice pods, the Kubernetes pods that are enabling those metrics. So to do that, we'll be writing this command kubectl get pods. Maybe I can increase the size of my terminal a bit. Please let me know if the terminal or any such font is not visible. I'll try to get it easier for you. But yeah, assuming that you already have kubectl installed, you can just simply say here kubectl get pods. In the namespace, the namespace that you had received earlier as part of this email. So if we go back to the email, it said that our namespace is this. For me, it's my first name, last name, suffixed by ns. So I'll be just be using the same. I'll be saying here kubectl get pods in the namespace Neelanjan Manna namespace ns, and we'll be using the kubeconfig file that we just downloaded. So for me, that happens to be in my downloads directory. You need to find it for your own directory, for example. So the name of the file is, for example, here my name suffixed by kubeconfig.yaml. So let me try to access it. So it's something like this. The entire command is something like this. I'm just sharing this command here in the chat so that you can simply copy and paste it. Just make sure to replace it with your own name. In place of Neelanjan Manna, you need to use your own name. Similarly, in this kubeconfig file path, you need to give the appropriate file path. So if I run this command, I will see that all of my application deployment pods are available over here. We can see that there are several microservices and all of them are essentially running. So please let me know in the chat if you are seeing any of these as not running, or like it's stuck in a pending state, or a container not created, anything apart from running. If the pods, any of the pod status is anything other than running, please let us know in the chat. All right, we have another question, which is IP address to be used to connect to cluster. We don't need really a IP address. The kubeconfig file that I just shared you has the appropriate credentials and appropriate, service account through which you will be able to access it. I mean, it contains all the IP address and the other authentication details. So please make use of that, Krishna.
So then how to get the kubectl command actually?
The kubectl command is this kubectl get pods in the name.
In my system, if I'm using my laptop, how to connect actually? I don't have kubectl in my laptop.
Okay. Let me just give you the download link. Kubectl. It's a simple utility. Just download it. This will help you to communicate with Kubernetes. I'm just sharing you this page. So based on your operating system, you can just select and follow the steps. It's pretty simple. Everyone else, if you also don't have kubectl, please download it. You won't take long. So for example, for me, it's Mac OS. So if I go to Mac OS, you will see that what are the different steps to actually download it. For Windows, of course, it won't be command based, but here it's all command based. So as soon as you're running all these commands, you're good to go. Let us give it a minute or so for everyone to get installed with kubectl. Or otherwise, we can actually just learn a bit about these application pods while others are installing the kubectl. So yeah, let me just do that. I'll just talk a bit more about what these pods are. So if you know Kubernetes, you understand that pods are the smallest unit of deployment in Kubernetes. On top of this, you can also have other resources that kind of implement the controller model in order to maintain these deployments or these pods. So for example, you have a deployment resource under which you have replica sets, as part of which these pods are created. These pods are the same microservices that you're witnessing in your Grafana dashboard. You have your front end, you have your shipping service, you have your cart service, you have your checkout service, your currency service. All of these are here. But apart from that, you will be also be seeing your observability stack present over here. That includes the Prometheus deployment. It also includes the Grafana deployment and so on. So that is how it all is working. This entire application is deployed here as part of this namespace. I mean, here in this Kubernetes cluster, all of these microservices are running. All of them have one pod precisely, and the entire application is therefore running over here. Okay. As you can see here, Sajid says that he has not received the sandbox email. Just a second, let me check. As I can see, Sajid, your namespace is already created within the cluster. So I'm not sure why you didn't receive the email. Can you just check the spam folder as well? Your namespace is already created over here, and just a second. And all your resources are also running. You should be getting the email, Sajid. Kindly check your spam folder as well. All right. So, all right, you say that you did want it for kubeconfig. So the kubeconfig file is also there within the this only the your email only. If you'll go to the email, you will find the kubeconfig over here. All right. Akash, will you please help them with the I'll be back in a jiffy. All right. Just a second.
Okay. If you are using if you are using your company email or something else which has any kind of filter for email or anything that might be blocking the email from coming through. Okay, then just give me a minute, I'll check.
All right, guys. Sorry for the interruption. Using personal check spam too. Ideally, you should have got the sandbox cluster. Let me check. Is there anyone else who has also not received their sandbox cluster details? Please let us know if there is anyone else as well.
Yeah, if anyone else also hasn't received the email yet, can you? Okay. Yeah, Sajid got the email.
You got?
Yeah, he just responded. Okay,
All right.
If anyone
Awesome.
hasn't received the email, please send your email as a direct message to me on the chat, and I'll look into it.
Awesome. All right. Thanks for confirming. So yeah, we can, I guess, get started with again, get going with our demo. Just a second. All right, guys. So please also let us know whether all of these pods that we just saw are also running for you or not. Let us know if it is not running for you. We'll be taking a look at it. But yeah, with that, actually, let's get again back to our setup. Also, I'm hoping that each one of you has also, oops, I stopped the sharing. Okay. Yeah, I am also hoping that all of you have also received your emails and you have also installed your kubectl. So yeah, with that, again, let me just share the details of our application. So you can see that with this command that I just executed, all of these application pods are getting listed over here, and except the Prometheus black box exporter, all the other microservices have only 2 pods. So That is how our Grafana dashboard is able to visualize everything. That is our application deployment in a nutshell. Now, what we are going to do next, if we go back to our workshop guide, we need to set up a chaos infrastructure. So now the question is, what is a chaos infrastructure? So as you can already understand that Harness is a SaaS platform. What you have signed up for right now is a SaaS platform. Here you have the chaos platform already. And as part of this chaos platform, you will be able to target to different experiments within your chaos infrastructure. So in this case, your chaos infrastructure happens to be this Kubernetes cluster for which we have just received access as part of this sandbox environment. And now we want to inject chaos within the applications in this cluster. Our application, of course, is this boutique application, and we'll see that how we can assess its resiliency. But the question is, how can we exactly target the chaos within this boutique application? So the chaos infrastructure helps us to do that. It's nothing but a agent that sits within your Kubernetes cluster, and it communicates to the Harness Chaos Engineering SaaS platform in order to execute the chaos experiments that are intended for it. So in order to install this chaos experiment, what we need to do is, first of all, we need to come to this tab called environments, and we need to create a new environment. Let us name this anything that you like. I mean, I'm just going to say here KCD workshop, and production or non-production, it doesn't really matter. You can keep anything. It's just a convention, and create. So as part of this, you need to now create a new Kubernetes infrastructure. So in order to do that, you need to select here enable chaos, and on new infrastructures you need to select. I mean, here it's on existing infrastructures is also there, which uses Harness delegates in order to install your chaos infrastructures. However, we don't have that, so we'll be using the on new infrastructures, and select continue. We can name this something like I'll just use my name here for the infra. You can use any name that you like, and select next. All right, so in this screen, please pay attention, because you need to ensure that you're only installing your chaos infrastructure with a specific namespace access. So you need to select this specific namespace access. And then you need to update the namespace where you are installing your chaos infrastructure. So for the Kubernetes cluster that you have received, you have also received a namespace where all your pods are installed. You need to install this chaos infrastructure in the same namespace. So just to explain you the difference between cluster-wide access and specific namespace access, cluster-wide access allows you to target chaos across every namespace that is present in your Kubernetes cluster. That is, applications present in other namespaces are also eligible for injecting chaos as part of the cluster-wide access. However, here you have access to only this specific namespace only. You don't have access to any other namespace within the cluster that you have been provided. So therefore, please select specific namespace access, or else your installation wouldn't complete. And then you need to provide the namespace in which you want to install this chaos infrastructure. So again, it needs to be the same namespace for which you have received access. In my case, it happens to be my name suffix by ns. So yeah, once you are making both of these changes, that is choosing specific namespace access and providing the name of your namespace, just select next. So we are at the last leg of the installation, wherein you have these 3 commands to be executed. However, if you have read the workshop guide properly, you will notice that these 2 steps have been already done for you. You already have this namespace, so you need not create it again using kubectl. You also have the CRD set up for you by default as part of the setup that had been done for you. So all you need to do is actually download the chaos infrastructure manifest with this download button. And once you have actually downloaded it, you need to copy this command that is present over here and go to your terminal and paste it. Now you might need to update this path. I mean, of course, this refers to the path of the file that you just downloaded. So for me, that path happens to be in the downloads directory. So I'll be just prefixing the downloads directory path. So in your case as well, please provide the particular path that you are using for this file. I mean, wherever it has downloaded, you need to just prefix the perfect path. So if I just apply this, I'll be seeing that all of these resources are getting created. So in your case, you need to apply this command with the kubeconfig as well. So you need to say -- kubeconfig with the file path of your kubeconfig as we had done last time. So if we scroll back, we had used this kubeconfig. Similar for you, you also need to use the correct file path and you need to provide it here. So I have already done this, therefore it's not showing for me again. But yeah, for you, you need to do this for the correct kubeconfig path. Otherwise, it won't be getting applied. So please let us know if all of these changes are done for you as well or not, or if you are having any problem with the installation. Please let us know via the chat if there is any installation problem. All right, let me also provide the entire command in the chat. So I've provided the entire command also in the chat. Again, please replace this the paths in this command with your own paths such that you are able to access these files at their particular download directory. And please let us know if there is any problem in doing so. We'll be trying to help you here. All right, so is everyone able to set up their chaos infrastructure? We'll be only moving forward if this step is successful for everyone. May I know who all have actually successfully done this step? Can I please have a note in the chat? Awesome. Anuj says that chaos pods are in running state. He also able to set it up. We'll give it 3 minutes so that everyone is on the same page. All right, let's give it a 5-minute break while everyone is setting up their chaos infrastructures. And meanwhile, if you have any questions or just want to drop in a hello, please feel free to unmute yourself, or please take some time back if you have already set up your chaos infrastructure.
So Nilanjan,
Yeah,
uh,
Anuj.
so if my application has proxies enabled, like the one with the Istio controllers, so does this harness work for that as well?
It will work. However, we advise people to use annotation in order for to bypass this Istio check, because, well, as you said, it is using Envoy proxies as part of Istio, so that might lead to a certain experiments to not be able to work properly. But yeah, we have support for that. I mean, Istio is not a problem per se. We just use a few annotations to skip a few checks or handle a few cases differently. That is all.
So annotations were in the chaos pods or the, because my app pods will have the proxy, right?
Yeah.
In the chaos pods, you mean?
Yeah, right. I mean, essentially, when you set up the experiment only, you provide those annotations. We can discuss it. I mean, we are yet to see how we create the experiments. You would see, I mean, how it's done.
And one more request, Neelanjan.
Sure.
Also, I wanted to mimic the setup
Mm-hmm.
for my test application. So I would also need the scripts for Grafana and Prometheus. How did you set this up? Like
All
I
right.
can check on my side how it's done, but I would like you to at least share the scripts.
Okay, just a second. Let me fetch it for you. All right, yeah, this will help you get started. This tutorial has everything that you will need. I'm just pasting it in chat so that you can also replicate it in your own environment later. Just go through this tutorial, you will find everything that you will need.
Cool, thanks.
Sure. So, would anyone like to tell us any stories about how they realize that they need more resiliency in their applications? I actually love to hear these stories from the field wherein resiliency is found to be an afterthought. However, that proves to be, a big mistake, and people then realize that it is a paramount consideration and should be taken more seriously. So if anyone would like to give it a go, or any stories from your prod or like your SREs or DevOps experiences, please feel to give it a go while we are taking a break.
I'm getting some error.
All right, Krishna, what is the error that you're getting?
So it's, can I paste in the chat? Actually, that message.
Yeah, sure. Feel free to paste in the chat. Let me see.
Not sure.
Okay, can you share the command that you were using?
Yeah.
Okay, that shouldn't have happened. Let me take a closer look. So, okay, as it seems, Krishna, you have mistaken a step.
Okay.
As I had told you earlier, I mean, it's fine. You can again redo the step. So if you'll go back at the step, I mean, okay, just a second. Oops, I did a mistake. Oh, no, it's already there for me. Okay, what I was saying is the mistake that you have done is if you'll go right now to enable chaos and on the new infrastructures, you just need to name anything. So for example, if let's say that I name this. Now you shouldn't be selecting this cluster wide access. You need to use this specific namespace access only. What you have done
Okay.
is you have created it with the cluster wide access. As I
Okay.
explained, cluster wide access gives you the ability to inject chaos in throughout all the clusters, throughout all the namespaces in your cluster.
Okay.
That essentially is not permitted in the kube config that you have downloaded. You have only access to one single namespace, and that is your namespace in this entire cluster. So therefore you need the specific namespace access.
So how you went to that step actually? Just can you repeat it again?
Yeah, sure. So for example, I'll name this anything, and then if I come here, you have
So
two options here, right? You just need specific.
for me, it's showing a little different. It's showing production and non-production something. Then
Okay, yeah, right. So that is the environments For example, you will be coming to environment, and if you come to new environment,
Okay.
that's fine. You just need to create this environment.
Okay.
Once it is created, I mean, you can select anything, non-prod or prod is fine. I mean, anything is just a convention here.
Okay.
Once it is created, you need to go inside that environment, and you need to come here and select this enable chaos over here. Upon that enable chaos on new infrastructures, and then this entire step. You just need to select here, specific namespace access, and change the namespace here to your own name. I guess that is Krishna dash Rao dash NS. That's all you need to do.
Okay. Okay.
After that, if you will be downloading that file, whatever file you are obtaining, you just need to download and apply it. I mean, it should get applied properly.
Okay. Okay. Thank you. Thanks.
Sure. Okay, so I guess most of you have actually been able to execute this. We'll give it another 2 minutes so that everyone is able to come on the same page, and then we'll be getting started with the infrastructure. Already, is there anyone else who is not able to connect the chaos infrastructure? Just let us know so that we can help you. Apparently, as you saw, it's a very simple step. You just need to download and apply it. But still, if you're not able to, just let us know.
Hey, do we have to execute that last step in the namespace or out of namespace? The default.
I'm not sure which step you're referring to. Can you elaborate, please?
Yeah, that one, right? Enabling that harness chaos, the last command. We download the
Um,
file and apply it, right?
Okay. Yeah, in that step, you don't need to execute the first two commands since it's already there for you.
Yes.
I mean, they have been already, the namespace you already saw that you have,
Yes.
and the CRDs have been actually been already applied for you. So you just need to download that manifest, the third step, and apply it with the given command. However, you might need to change that command based on the file. Excuse me.
Possible.
Yeah, right. The path. That's it. That's all you need to do.
Not the namespace, not hyphen namespace or hyphen n. With the
Yeah, dash and namespace. Yeah, dash
namespace.
and. I have also given the command in the chat. Actually, let me try to again paste it.
Neelanjan, this time the command went through, but the pods are in the pending state. This is I see this message actually CPU is not sufficient or something.
Okay. Just a second.
I given the error message.
Okay. Just a second. Let me check. All right. I see. Okay, not an issue. Let me fix this. If anyone else is also facing this issue, will be coming through this. I'm just checking if this is the issue. Okay, I'm just resizing this cluster so that everything is okay. Just wait for a few minutes. The resizing of the cluster will complete and we'll be able to get through. Sorry for this inconvenience.
Neelanjan, one thing, like I did create the environment, but I don't see this KCD workshop chaos infrastructure.
Okay, I mean, KCD workshop is not needed. Whenever you're creating an environment, you will be
Yeah.
guided into it. KCD workshop is the name that I had given, for example, to my infrastructure. You can name it whatever you want.
Yeah.
And
Okay. So
Mhm.
I created one environment.
Yeah.
Now I don't see the rest of the windows. Like I'm
Okay,
clicking
so
some of
you're
the configuration
yeah,
pieces.
right. Yeah, right. So you see this enable chaos button in the middle, right? I mean, connect your first chaos infrastructure, something like that. And if you open it, something of a similar window
Currently,
comes.
I'm not.
Okay, so which screen are you in? Feel free to actually share your screen. Let me see. That should be okay. I guess you also don't have permissions. Okay.
Can,
All right. So what do you see right now in the screen? I mean, okay, you have
can you see
permissions.
my screen?
Awesome. Yeah, right. All right, you're in this screen. Okay, fine. Did you not select chaos? I mean, in there, this is actually in the environments that you are. Can you go to the default project under the project? Yeah, and select the default project. Okay, you are under the CD module. Actually, this is not the chaos module. So just select beneath the project. There is a options icon, right? Can you select that beneath projects? Yeah, that one. Here, select chaos engineering. Yeah, start chaos free plan. Continue. Enable chaos. Yeah. Yeah, right. Go into that. Awesome. You're ready to go. You can do the exact
Thanks.
steps now. Yeah,
Thanks.
sure, sure. All right. Assuming that most of you have actually connected it, let us conclude our break and we can now actually get started for the next leg of our workshop. Hopefully you are having fun right now. I'm definitely having fun. So from here, we are actually going to discuss a bit about the chaos infrastructure and how we'll be doing it. However, from here, Akash will be taking you through this workshop. So Akash, the stage is yours. Please commence the rest of the workshop.
Yes, thank you. Okay, great. So I guess everyone, as Neelanjan mentioned, has been through all the steps and we can proceed forward. So basically, now since we have already connected our second, yeah, I hope my screen is visible to everyone and my audio is also
You're good, Akash. Go ahead.
okay. Great. Thank you, Neelanjan, for the confirmation. Great. So now since we already have a kiosk infrastructure connected. So the next step is basically to create an experiment, right? But before creating an experiment, we need to load up a kiosk hub. So if you go to the kiosk hub section here, you will see an enterprise kiosk hub. So this enterprise kiosk hub contains the experiments that Harness Kiosk Engineering offers, which is like divided into different categories. So we have experiment for AWS, for Azure, Windows, for Kubernetes, for Kubernetes nodes and pods, as well as GCP, Spring Boot applications, VMware. So we have for both Kubernetes and non-Kubernetes based experiments available in the enterprise kiosk hub. So you can go through it, see what experiments are there, and then you can try building up your own scenarios. But right now, there are two things you will see: chaos experiment and chaos false. So chaos false are basically a singular fault, which is basically will be going and doing one single thing into inside your application. Supposedly, like if I do pod delete kiosk fault, then it will go ahead and delete the delete whatever specific pod or pods that I provided it to delete inside the application, right? And we can set up these singular faults into like one experiment where we can have multiple uh, faults available, right? So this is something that you can devise by yourself, like basically having a specific set of experiments that you want to run in parallel or serial modes, which we'll be talking about further, and then create it as an experiment, which you can use here, right? So this is something that Harness provides by default, but there is one more option available, which is to create a new or connect a new chaos hub, right? So chaos hub is nothing, it's just a place where you can store your experiments, right? And since like it's harness chaos engineering, you can add in your own experiments also as per you can design your own experiments also. So if that is the case, or you have stored them into at a in a Git repository, then you can connect your own chaos hub and use your experiments, right? So for the for the ease of process and benefit of this workshop, we already went ahead and created one chaos hub which we can utilize here, which contains some chaos scenarios that we can use and run it, right? So if I will just provide this link in the chat. Right. So this basically contains some experiments and some faults that we'll be running. So how to connect a chaos hub? It's a very simple process. Once you are in this area in the chaos hub section, you'll see a new chaos hub button here. Click on it, and then after that you can name your chaos. So I'll just name it KCD workshop. KCD workshop chaos hub. So you can name it anything you want to. It's not mandatory to add chaos of anything, but just for the sake of simplicity. Now you need a connector. So what is a connector? Connector is basically you can call it as an as something that you can utilize to connect to different services so that you can use it inside the harness application. Supposedly like connecting GitHub, connecting other Git-based applications, connecting GCP, connecting AWS, S3 buckets, anything, right? So you can basically connect them here. So if you have a file, the repository contains the experiment that just I showed you. If you want to access it, then you can use these connectors to access them, right? So for doing this, you basically need to click on new connector. Right now, there are three levels here where you can define this. This is something that's at harness level thing, not specific to chaos. It's about the whole harness software. So project is the base. It's the account is the base level. It contains everything inside it, and then inside account you can have multiple organizations, and inside each organization you can have multiple projects. Right. So right now we have our own account and a default organization inside it, and then a default project. So I'll just go ahead and add a connector inside the project. You can just click on new connector here, and you can select your connector type. So since the repository, since the chaos hub is in GitHub, so we'll connect GitHub. Right. I can just need to name this connector. So I'll just name it as GitHub connector or anything you want to describe it. You can add descriptions or tags as per your use case. So this helps you to categorize the connectors. Yeah. Now next step is basically asking it what we need to provide. So we just need to provide an access to a repository. So we'll just select repository, go ahead, copy the link of the repository, paste it here. Connection type would be HTTP. Since we'll be providing a GitHub personal access token. Yeah, so it basically requires some kind of authentication here. So for this authentication, you need to create a GitHub personal access token. So the step is like very simple to do. I'll share this guide here in the chat as well, so you can utilize this. So what you need to do is you need to go into your GitHub account, then click on settings, and then you'll see a developer settings option at the left hand side of it, right? And in that, you will see a personal access token written, and then click on fine grained tokens. Fine grained tokens will basically minimize how much access you are giving to your account using these tokens, right? And then after click on find in token, you have to click on generate a new token. Okay. It will open up a screen asking you for some information. You need to give the token a name. You can give it the expiration. You can set it tomorrow because you think it's just for today. And then under resource owner, you will see a checkbox that says public repositories. So you just need to tick that only. Don't have to give any other access or anything else required. And then just go down below and create the token. So that will give you a personal access token, which we will be needing to utilize here. Okay, so I'll just my username, and then if you click on create or select a secret, so Harness has its internal vault management system where you can define and create secrets which will be storing with encryption with encrypted, and then you can utilize these secrets in your different sets of area, right? So here I'll need to create a secret which I'll be using here. Right, I'll just pause my screen. Great. So basically, you just need to name the secret, and then you need to provide the secret value here. So this secret value is basically what the token that was created. It will basically give you a token value, which you need to provide it here, and then click on save. Okay, so now I have a secret created, and I have also defined the credential for this customer. I'll just basically click on continue, and it will ask me how do I want to connect it. So there are two methods to connecting it. What we need right now. Okay, sorry, I clicked on the wrong button. So meanwhile, is anyone having any issues in connecting or creating a secret? I guess everyone is able to create a secret in GitHub and then add a secret here in the Harness vault. Okay, great. I don't see any questions popping up. So great then. So yeah, so there are two methods to do it, connecting through Harness platform or connecting through a Harness delegate. So Harness delegates are something that, so since it's a SaaS platform, if you want to connect it to your own clusters or to your own environments, you need to use something to have that connection, right? So Harness delegates, it's something that facilitate that for you. So you can connect a Harness delegate, which will be installed on your cluster, and you can use it to perform different Harness functionalities, like connecting to the provider for the connector you are creating, or even installing the the kiosk environment that we just did. Right, so all of this, but right now, since we're not going to the delegate part, we'll just basically connect to the Harness platform. So you need to select connect through Harness platform, and you need to click on save and continue. It will just validate the authentication permissions, and you'll just see this verification successful. Click on finish, and you'll have your hub connected. So now, since we have a connector here, I just need to mention the branch on which I need to do. So since this is the main branch that contains everything, let's mention main here, and then click connect on hub. Great. So the hub is connected, and we have our own custom hub connected here, which we will be utilizing to create experiments or create or use the policy, right? So if anyone have any issues till now in connecting the hub, or we're not able to follow through properly, or is any doubts, please you can speak up, or you can ping it in the chat, and I'll be happy to solve it so we can move ahead.
I guess it's worth noting that the hub is nothing but a collection of manifests that represent a real chaos experiment within the Harness platform. So it's a collection of files that enable different faults or the different experiments, which are represented in a declarative way using these faults. So yeah, please continue, Akash. I guess there is also a question for you.
Okay, token and secret creation is not clear. Okay. Cool. So for token creation, I shared a link on how to create a token in GitHub. Basically, okay, I'll just try to show it. Okay, just give me a minute. I'll share my screen once again. Okay, so you will see this developer settings at the very left, right? And when you click on it, you will get this screen here. You need to click on personal access token. You need to click on find rings token, right? This will basically give you this screen, and then you need to click on generate new token. Okay, give the token name, set the expiration date. You can click on custom and set it to a specific date you want to. I'll just set it to 1 day. Right. Resource owner, select yourself as a resource owner. And then in the repository access, just the default is public repository only. Let it be this. And you don't need to change anything else. You need to click on generate token and it will generate a token for you. Right. And on that screen, you will see a token here and a copy button. So you just need to copy that token. Right. That will give you your GitHub access token that we need to utilize while using it for the connector. Right. I hope this much is clear. Great. Great. Now, if you go to the next step. Yeah. So now here, when you click on new chaos hub, you give a name to this. Right. I'm just not creating one. I'm just showing it to you. We click on connector. You need to click on new connector, select the GitHub connector, name it something. Okay. Here you need to click on repository, provide the name or provide the link to the repository, which I shared in the chat. Right. Now here you need to provide your GitHub username. Once you provide it, then you need to click on create a secret, new secret text. Right. And here you need to provide any name to a secret. It does not need to be something specific. You can provide any name. In the secret value section, you need to paste that GitHub token that you just created, right? And then that's it. You can click on save. This will create a new secret for you. Now you need to select that secret, or it will automatically select it. It will show up here, right? Click on connect, then click on continue, and then select connect to Hans platform. Save and continue. It will test whether you have connected properly or not connected properly, and then it will basically show you the GitHub connector selected here, right? Like this. Then mention the branch name, and then we are good to go. Okay, sure. Neelanjan, you can share the documentation also for the architecture part, the chat ones.
Sure, or maybe in the end we can just briefly talk through it. We'll be covering that. We'll try to cover that in the end if possible. Sure, Abhishek.
Yeah, if anyone has any issue till now connecting the hub, so it's like a very so you can connect any number of hubs you want to based on your requirement. So this comes in very handy when you're using it inside your teams and you have created your own specific set of experiments that you want to utilize, right? So you can create in one place you can create and then you can utilize it at different places. Also, like if you want to store it inside your own repositories for like for your own use cases, you can just store them and then utilize it here directly. This gives a good option to connecting hub. We'll also see how to create a experiment and how we can just like store them inside a repo so we can utilize them. Great. I think everyone was able to connect to Hub. If anyone has an issue, please feel free to put it in the chat. I'll just move on now. So yeah, if you click on this, the Hub, you will see there are some chaos experiments available, right? Um, Basically, boutique cards CPU starvation, boutique cards degraded network, boutique cards pod bounce, boutique card multi-fault scenario, right? So these experiments basically use these chaos faults, pod delete, pod CPU hog, and pod network latency to create different set of scenarios with some probe health checks as well to so that we can test the resiliency of the application that we're running, right? So as I mentioned, using these faults, you can create different experiments which will help you test out the resiliency of your system. Then you can run these experiments as many number of times you want to. So basically, pod delete is an experiment. I'll just go through with what this fault does, right? And this will give you a good uh, knowledge, or this will give you some clarification about what we're going to do. So pod delete is a fault which basically goes and deletes the pod or in any number of pods that you have specified according to what config we are providing it, right? And based on our application, whether our application is able to restart those pods, or is it able to restart them, scale them up again, or how many replicas or how many uh, backups we have available, so that our application does not go down when something of like this happens. So pod delete can be a scenario which can happen in any Kubernetes application due to multiple reasons. Like if there isn't enough memory or CPU available, so the pod can get home killed, or it can get evicted if it's using too much storage or memory, right? So that's the thing. Okay, I see a question. Mine is still in pending state. Okay,
I'm
so
looking into it, Akash. Wait. Yeah.
yeah, so that's one scenario, one case you can mimic using the pod delete experiment. Pod CPU hog is also similar. So I just mentioned, like, your pods can run out of CPU, or when they are utilizing too much CPU, they can get evicted. Or with high CPU, also when there's not enough CPU available, your application will slow down. So like, how do I simulate that kind of scenario, right? So pod CPU hog will help you do that. It will basically increase the uses of the CPU that is like the pod is utilizing, and then you can increase it to any certain amount you want, to a certain percentage of total memory available. So that will give you a kind of simulation when there is like a lot of load coming to your application, or when your application is doing some memory intensive tasks, and we can simulate and see how is your application performing under those intensive tasks, right? And then we have pod network latency, which basically adds some latency to the network connectivity of the pod with other pods as well as the internet. So we can fine tune what connectivity options we want to add latency to. But this will just basically simulate a scenario, simulate a situation where your pod is not able to connect to different services because of, like, either when certain scenario where different services are not working properly, or when the connectivity between them are hampered due to some kind of networking issue or mesh issue, service mesh issues, or when your nodes are not able to connect to the outside world or call any third-party APIs, and or either the third-party API has some kind of latency added to them, right? So these kind of scenarios you can utilize with the pod network latency. So according to them, we have created three experiment sets which will help us to simulate these. One is CPU starvation, where we hog the pod resources and see what happens when we are, like, continuously hogging them, when we are utilizing a lot of the CPU memory, how our application is going to react to it, and is it able to still hold up the SLOs and with that SLAs that we have defined, is it still able to serve the customers properly even after these kind of scenarios, right? Then we have the boutique card degraded network, which will basically create or simulate a situation where the network is not working properly, or there's too much load for the network to handle, load balances are not working. So there are a lot of scenarios, like cases because of which this can happen. So this will stimulate that, and it will help us know whether when we're trying to connect to the service, whether it's able to properly work or not. And then we have the boutique card spot bounce. So that is basically simulating the eviction or rescheduling of the pod by deleting them. So this gives us a feel or simulation of the situation whenever pods get if evicted, or when a pod fails to load or something, and whenever we are rescheduling the pods, whenever they are restarting, you can see how much time it takes, whether we are able to have some kind of backup pods running already, how many replica sets we require for these kind of scenarios. So we can set these up, right? And then at the end we have the boutique multiple fault scenario, which basically is a culmination of all three of the faults, which run one by one, and we can have multiple faults running in a single experiment, so that we can create our own experiment scenarios where we want multiple specific things to happen also, right? So this is to just showcase that. So that is what all these experiments are going to do. But before running these, I'm going to show you how to actually create your own experiments, because that is the very basic of harness chaos engineering, right? So if you click on chaos experiments, you will get the screen. We don't have any experiments right now that we've created. I'll just click on create a new experiment, right? I'll just name it boutique shop test experiment, right? You can name it anything. Now here, selecting a chaos infrastructure, this is where we need to select the chaos infrastructure we just created, right? It will show up your screen like this. It also shows how many experiment runs. So this basically like how many experiments you have run on this infrastructure, or how many experiments you have created for this infrastructure, right? So this will give you that information here itself. We click on apply, we're going to click on next. So it's going to give us some options here, right? So we have multiple ways through which we can create a chaos experiment, right? Yeah, we'll go through how the network latency happens when we are injecting that chaos. We'll be going through each of the experiments, specifically what variables we have in them, right? Yes. So back to this. So we have three options available here. One is blank canvas. So this will basically give you empty screen, and you can just add whatever faults you want to add, whatever probes you want to add to them, right? So this is basically like creating everything from scratch. Then we have templates from Chaos Hub. So you can, as we just saw the chaos experiment site. So these are basically templates which we can utilize here to create our own experiment from those templates. So templates can give you a starting point. If I suppose select the booting multi-fault scenario, this will give me a starting point, something like this, right? So it has the install chaos step and these three experiments running parallelly, right? So this gives me a starting point from where I can build something more, or maybe I can do some changes, right? So template is something which you can create it once, and then multiple people can utilize it according to the needs. So this is one other way. Third is uploading a YAML. So this is basically like if you are very comfortable with using manifest directly and you want to directly edit the manifest, or directly work with manifest, then you can do that as well. You can just click on upload YAML, and that will read the YAML and basically set up your system here like this, right? Since these experiments and faults are basically manifest at the end, right? If you go to experiments, you will see it's basically an experiment.yaml. It's a manifest file, right? So generally, like if you're comfortable with them, you can just utilize these manifest directly and just click on upload YAML and then utilize them, right? So this is one more way of creating a chaos experiment, right? So just to give you a hint how to add something, we'll just start with a blank canvas. Click on this. This will give you an empty screen here with an add button. So this is basically a pipeline where you can add multiple steps or experiments, right? And then you can run those. If I click on add, it will show me the chaos hub. So I have two different chaos hub, enterprise and KCD workshop chaos hub, right? So I'll just select KCD workshop to remove all experiment I won't be requiring. So it has three experiments. Suppose I select the bot delete experiment. Now it will show me the screen to fine tune my experiment and provide the configs so that I can inject it on the specific application I want to, right? So first I need to select the app kind. So what I'm going to deploy it on is a deployment, and then the app namespace. So Neelanjan, Manna, which the namespace you have access to. Whatever namespace we will your kiosk connector has access to, kiosk infra has access to, it will show up here, right? And then app label is basically it will show up whatever app label is available inside that namespace we have provided, right? So everything is UI based here. You can just scroll down and select whichever you want to. Suppose I want to inject it on the catalog service, right? So I select this catalog service app label. Now we have the tune fault section here. So this is what this is where you can fine tune and kiosk experiment or kiosk fault, right? So it has different config values that you can provide to make it work according to your own requirements, right? So total kiosk duration is basically how long you want it to run for. Okay, so if I provide it 60 here, then it will run for 60 seconds or 1 minute. So in that time period, what it will do, like suppose I'm running pod delete, so it will delete the pods and delete, and it will wait for 60 seconds, and then after that it will run the probes that we want to, right? If you're talking about some experiment that works continuously, like the network latency experiment, then it will block your network or add latency to your network for the total kiosk duration of 60 seconds, right? So you can define what duration you want to, right? RAM time is basically how much time you want before and after the experiment is running. So basically this is to set up a few of the stuff that if we want to, supposedly like if my pod has some kind of time, it takes some amount of time to actually restart, right? And I have a probe which checks for the pod, so I would need to provide a RAM time to facilitate for that time that my pods take to restart, right? So you can utilize this variable here. Force is basically something specific to pod delete. It tells you like if you want to delete the pods forcefully or you want them to shut down gracefully. Kiosk interval is basically the time interval between experiment iterations. So if I set the duration as 30 seconds, I set that interval at 10 seconds, so it will run it and then wait for 10 seconds and then run it again and then wait for. So you can have multiple iteration inside one fault itself by maximizing on the duration and kiosk interval config files, right? Pod affected percentage, you can define what percentage of the pods you want to do. So if like suppose you have say 10 pods and you want to 60% of the pods to be affected, you provide a 60 value here and it will delete 60% of the pod. So you can set up how much effect, how much rate, how many pods you want to delete. You can specify using this. Target container will help you to specify a specific container that you want to target, you want to delete. You can just provide the container ID here and it will work. For target pod, it works the same. If you want to specifically target one specific pod or a few of the pods, you can provide the values here and it will just go ahead and delete those pods only, right? So you can use these three to define how much of area you want to target, how many pods you want to target by using these three things, right? Then we have the node label. So if you want the pods to be deleted on one specific node only, which are running on one specific node, then you can provide that node label here. That is defined inside a pod as well. So this will basically delete all the pods or delete whatever values you have provided here based on them on the specific node only, right? Then the sequence. So basically when we are running it for multiple pods, suppose I'm running it for 4 or 5 pods, how do I want it to happen? Do I want it to run in a sequential manner, like pod 1 gets deleted and then we wait, and then pod 2 gets deleted and we wait, pod 3 gets deleted? Or I want it in a parallel manner, like all of the pods get deleted at one single time. So I can define it here, right? So I can define serial if I want it one by one, or I can define it parallel if I want all of them to happen at the same time, right? And then we have the tuning fault weightage. So basically one experiment can contain multiple faults, And according to your requirement, it might be that the pod delete experiment is one major experiment, and network latency is something that is not very major to you. So we can define the weightage on a scale of 1 to 10. And based on this, we harness chaos engineering will calculate a resiliency score for you based on what pod weightage, what fault weightage you have provided, and if whether the experiment is failing or whether the experiment is passing, right? So on the basis of this, you can, after every experiment, you can get a resiliency score, and according to it, you can define your SLO, like this much is how is the resiliency score that you want to maintain. Whenever it goes below that resiliency score, then you need to look into like what's going wrong, and then you can reiterate over stuff, and then improve it, and then get above that resiliency scores level, right? So this fault weightage will give you that fine tuning to tune which fault will basically contain how much of weightage in the calculation for the resiliency score, right? So you can set it from 0 to 10 depending on whatever is set. And then after setting these up, you also have this probes option. So in every fault, you will see a default health check probe. So this probe is basically at the start, before the start of the experiment and after the completion of the experiment, of the fault, sorry, not the experiment. This probe basically checks out what is the status of the application that you have targeted, right? So in the initial step, we provided one target application here, right? So this probe will basically go ahead and check it out. Yeah, Sajid, can you message as everyone, so Neelanjan can probably help you out on this? Yeah, so health check, so you will find a health check probe. So this probe basically checks whether the application you have mentioned is up and running before the start of the application and after the start of the application. Because it's like if it's required to run to pass the basic health checks, right? Whatever application you're targeting. Suppose like it has before start it's running, so that we can inject chaos into it, and after completion is still running, so that we have come back to our original state, or come back to our original state of the application where everything was working fine, right? So to facilitate those, we have this specific probe here, health check probe. And you can deploy a new probe as well, right? We can name it, and then we have 4 different kind of probe: HTTP, Kubernetes, Prometheus, and command probe. HTTP probe you can utilize to add any kind of checks you want to in terms of calling any HTTP endpoints. Supposedly, like in the boutique app application, I have some endpoints, some health checkpoints here available, which I can call and see if the service is up and running or not. So for those health checkpoints, you can just use the HTTP probe. Using a Kubernetes probe, you can check for Kubernetes specific pods or any Kubernetes specific application, and see whether it's running, what is the state of the application, right? And what is and see if it's in the correct state or not state, right? And then we have the Prometheus probe. This you can utilize to use it with the Prometheus exported logic. Prometheus probe, which basically helps you out like to use with Prometheus exported data, and you can utilize it there. You have also the command probe. So command probe will basically give you access to run your own commands to test out something. So specifically like with this health check probe, we are using a command probe. If you go to the probe details, you will see that we are running command here, which basically does something. So you can also provide your own image, which we call it a source command probe, where if you provide your own image and you provide a command, it will run that command inside that image. So you can define your own binaries or define your own kind of checks you want to inside that image, and then just run it as well as here. So this gives you a lot of flexibility in terms of what checks you want to add. You're not just limited to some specific types of probes here. If we're using the command probe, you can have a lot of flexibility in if you want to provide some very specific checks, or if you want to use some specific tools or binaries to add some checks. So that is something that you can get on with command probe. So if I select STD probe, I have different modes here also. So SOT means start of test, EOT means end of test. So basically, during a chaos experiment, like chaos fault life cycle, there are different places that's called start of test, during chaos or on chaos. Then you have the end of test. So before the chaos is injected, that phase is called start of test, where we basically check the health of the application, set up our initial pods and initial setup and initial injection steps and everything. That is the phase where the chaos is not injected, nothing wrong is going on, as in like nothing has been injected into your application, so it's not going on anything else. That's called start of test. Now during chaos is where we actually start the chaos injection process. So for like pod delete, we start deleting the pods. So when that's happening, that's called the on chaos test. And when that completes, when we are done with deleting pods, when we're done with the chaos, then that's called the end of test. So you can define a probe to run at these different specific sets as well, using SOT, EOT, or on chaos, or you can run it in edge mode. So edge mode will basically run it at the start of the test and at the end of the test, right? Which basically we are running for the health check here. So this will basically run before the application start, before the injection, chaos injection, after the chaos injection. Then you also have continuous probe, which will basically run for for the complete array of application. It's basically like if you want to run a specific suppose API health check, right? So you can use it in a continuous probe mode. It will continuously check for the API and see whenever it goes below a specific area. Or you can test out the latency also. So it will basically test out the latency at the beginning of the application, and then once it's running, the chaos injected will keep testing it out. So you can see how like whether the latency is coming down specific percentage value, and it also helps you to to see it whether it's whether the latency what that value before the chaos injection. To validate the situation that you provided it, how much time it's going to wait for it, right? And then how many times it's going to to retry also. Probe interval is basically interval between the probe calls. So if suppose you're running continuous probe, if you provide a 2-second interval, it will basically every 2 seconds the probe will run whatever command or whatever process or whatever endpoint you have provided it, and then it will keep on doing this, right? Then we have the polling interval. So polling interval is basically like after every iteration, it's basically goes to sleep and then come back in. And then we have the initial delay. So if you want to add some delay to the probe, suppose I say if I'm running an on chaos probe, right, and I want to wait for 5 to 6 seconds because that's the time my pod will take to actually get in the delay tested, or like I want to add some kind of delay to enact a scenario where 1 or 2 second delay, that's like my wait time, that's can be allowed. So you can add the delay here also, right? Then there's stop on failure checkbox here, which is basically if the probe fails, then the experiment will stop. So that is useful if you want your experiment have multiple faults and you want to stop it whenever it fails. You don't want to run anything else. So it's helpful when you have an experiment with chaos fault that are interlinked, like dependent on each other. So you can just add a stop on failure. If you want, if they're not dependent on each other, if you want to run them continuously even if the probe fails, you can just keep it unchecked always. If you click on continue, you will find some probe detail, which is specific to the type of probe you have provided, right? So if you have provided STD probe, you can see you can provide a URL here, and then there's skipping the certificate checks, which will basically, if you provide a HTTPS URL, then you can check this box here. So this will like basically not fail when the certificates our checks are failing, right? So if you want to do that, if you are providing HTTPS URL, then you will need to do this. Otherwise, you will good to go without providing this. Then you have the method here, which basically gives you get a post. So if you want to call your API with get or post method, whichever you want to. If we select post, then it will give me some more options here, content type and body. So if I want to give something inside the body to the post URL and see what output I'm getting, so you can do that as well. And in the get, you will just get this, and you need to specify the criteria. So this is basically the response code. We basically check the response code. So whatever criteria you provide here, it will check it out from the response code you have provided. If I do one off, then I can provide multiple response code with comma separated values. So it will basically see if the response code I'm getting from the API is one of the response code I provided below. So you have multiple options here. You can just select it, then you click on set up the probe, and it will just basically add a probe here. Right. Click on apply changes, and then we have a chaos fault added to our experiment here. Yeah, we have a chaos fault added to our experiment here, and you can see whatever changes you did. So that's adding a fault. You can just go ahead and add another fault as per requirement, add CPU hog, select star, right? And basically it will just add on a number of experiment faults you want to. Then you need to click on save. So here you can see an option like add experiment to chaos hub. So if you have connected your hub, right, and you click on it, it will give you an option to actually add this experiment to your own chaos hub. So this is how you can, create your own set of experiments with each scenario, the fault you want to, and then you can add them to your own hub, so you can store them right here. Okay. Or one more option is like saving it. So that's when you save it, this will save it in the harness with harness only. It's not going to add it to your chaos hub, so will not be pushed to your GitHub repository. When you click on add experiment to chaos hub, this will push this experiment manifest to your Git repository, whichever hub you are connected, and it will just basically add it there, and then anyone having access to that repository can utilize it, that hub and that specific experiment to their requirement as and when where they require it, right? So that is one way you can save it. So once you click on save this experiment, it will save it. Now you will get a run option here, and you click on run, it will start the experiment. I'm not going to run it now. I'm just going to stop it. Yeah, so that is how this basically is going to work. And then you can edit it again from here, save it, then run it again, right? You can clone the experiment. You can download the manifest. As I mentioned, like you can download the manifest and you can create experiment from the manifest directly itself. So great. These are the ways you can create an experiment, fine tuning you can do with an experiment. Right, so I've gone through the pod experiment mostly. With the next set of experiments, I will be going through the different experiment, the network latency in CPU hog and how they work. Other than that, you can have read about them by yourself, about the different experiment that is available by going to the developer.harness.io website. This gives you documentation into chaos engineering. This basically gives you whatever we just told about getting started, like how do you connect an infrastructure, how do you create an experiment, right? And how do you connect it to hub and everything. And then we also have this section, chaos section, chaos experiment section, and probe documentation. So probe, here you can see what all probes are available, right, and how to add a probe is there, and then using this section. Then you also have chaos experiment, which basically have the details about how to create experiment, hold them, exporting them, editing them, deleting them, right, and adding them to a hub, or using the chaos dashboard, like basically to see what experiment you have done, what all resiliency scores you have in them, right? And with this also you have one more thing. If you go to technical reference, you can see different chaos faults that are available. If I go to Kubernetes, if I go to if I search for CPU, right? So I have this pod CPU hog experiment here. So this gives me, if I click on details, it gives me like a basic setup and information about what this experiment does. how it actually works internally, and what all user inputs or what all tunables I can provide, right? So there are two types of tunables, optional and mandatory. So you will find a mandatory section here with some experiments. So mandatory are tunables you have to provide. Without them, the experiment is not going to run. And optional are some tunables like which have either some default values already provided, or like, so that's why you don't need to provide, or then, or otherwise they are like, we have suppose like with target pods, a target container, even if you don't provide it, it will randomly select any of the pod and delete it. So that is there. So you will find some tunables here, what all tunables are here, and then you also see some examples. These are manifest based examples where it tells you like what envs you need to provide. So like for like injecting CPU hog on a CPU core only, it gives you a example of how you can do this. Or if you want to use CPU load, it gives an example, right? We have the examples here, and then this is basically giving you an idea of how the experiment ran, right? So it basically like you tune it, you provide it to execution plane, and then the execution plane will derive the pods, derive the containers, and then basically launch the stress process, which basically adds like utilize the memory or CPU or disk IO based on what experiment you are running, and then it waits for the chaos interval, runs these probes according to whatever mode we have provided, and then it provides the results to us. So you can see it for any of the applications you want to here inside the documentation. I'll provide a link to this as well. And you can also see the architecture of how this works, like how harness chaos architecture works. What is chaos infrastructure, what execution plane, what is control plane, right? So this all information you can get into. We'll be going through this as well after at the end of this chaos experiment demo, right?
Yeah,
Okay.
Akash, there was a question regarding why or like how exactly the network latency happens here. So you can
Yes.
maybe just give a brief of how it works.
Yes, sure. So I am going to go with it once I start running the experiments, right? So that will like just give a good idea of when the experiment is running also. But okay, I'll just give you a little bit of information from the doc itself. You can see. So if I just select Kubernetes, sorry, I couldn't find it. Yeah, so if I select latency here, I have for network latency. Yes, so this diagram would help you get to know. So it's the base process for Kubernetes experiment is simple, like deriving the pod list and everything. Now, once we have derived everything, what it does is like it creates some traffic control rules inside that specific pod that we want to inject chaos on, and then according to network according to those traffic control rules, the network or the packet uh, what is the packet or the network connectivity between egress and ingress to that pod gets affected according to those rules. So if I supposedly like okay, I'll just once I get into this boutique are degraded, once we're running this, you'll see what all tunables are there, and then that will give you a better hint of like how it actually happens, right? So okay, so let's start with boutique card spot bounce experiment. Okay, so this is like the pod delete experiment fault, and we have added some probes and everything into this, selecting and chaos and okay. So till now, I guess this was a lot of information I just gave, and I guess there might be some amount of like questions or queries that you would be having, right? So please feel free to put them in the chat. I'll take them up if that's like part of the process, or maybe Lanjan can give you a answer in the chat itself if it's like a common query or something, right? Great. Or if anyone, if all of you wants to like have a 1 or 2 minutes break, we can take that as well, or I can continue. Right. So okay, okay, I guess I can continue. Great. If anyone is having any kind of doubt, please feel free to ask. So that we know that there is something that we need to explain a bit more, or something that's need some kind of explanation, right? Yes. So basically, this is the same step that we did in the chaos experiment. Just right now, we're using a template, which I just showed, right? So you can either use a template from going to chaos hub and then selecting this launch experiment button here. You can use it through the template option that I just showed also. So these are two options. Select the chaos intersection. I would like you all to follow this as well with me. So you will also see it happening inside your own namespace as well. So you can see it happening. You can see how it's actually working for you as well, right? So please go to the chaos hub, select the boutique card pod bounce experiment, right? And you can right now it's fine. You can just keep this here. But like if you're running it multiple times, it is good to remove this name or just add some random value to this, because the chaos name needs to be a unique name here. Okay. So it's not required right now to change it, but if you're running this multiple times, then you will need to change this. So great. So yeah, select a chaos intersection, select the chaos intersection, and then click on next. If anyone had any doubt till now, anything, please. Okay, great. So yeah, so this basically has my experiment is basically showing up here. Now, when I click on it, you can see it in the tune fault section. There's basically the values are already provided. Okay, and you can see the probes have been added also. We have 3 different types of probes. We do not need to change anything here. Some of the values are not showing up here because like we have provided some default values which will be taking up. And I'll just keep it at 30-second chaos duration. Now let's talk about the probes that we are going to run, because these are like so probes are the basic checks or which sets up what is going to be your like how do you actually test your hypothesis, right? So before doing the chaos engineering, and Neelanjan mentioned at the very start of this workshop that whenever you're doing chaos engineering, you initially set up a hypothesis like this is my application and this is how it's going to work, and if certain condition comes up, this is how it's going to react, right? So that's your hypothesis. But how do you test the hypothesis after running this chaos experiment, right? So if I have a hypothesis that something like this happens, so I need to stimulate that. For doing that, I'll run the experiment, I'll run the fault, right? But how do I test whether my application is performing according lead to the like whether it's passing the hypothesis or not, like whether it's working as per the requirement, as per the thought process, or whether it's working not exactly like this. So probes are something which is going to help you check that, right? So we just talked about different kind of probes. Now let's talk about like how right now we are trying to like work out a hypothesis, and how right now we are trying to simulate and then test out whether what we thought, what we hypothesized is working properly or not working properly, right? So we can see we have 3 different probes here. One is a CMD probe, HTTP probe, and a PROM probe, right? And the command probe is running to an edge mode, basically start and end. PROM probe also running a start and HTTP probe is running at continuous. Okay, so if you see the probe details, so this command probe is basically the status check, the default status check that we just talked about. So this will basically check the status of the application, whether it's running properly or not running properly. And if it's running properly, only then we go ahead and inject the chaos. And after the completion of the application, we check whether it's running properly or not running properly, because at the end of the fault execution, we need the services to be back to the normal state that they were before, right? That is the revert chaos process, or that is like a cleanup process for chaos. So when you're running experiments or when you're running faults, the damage should only be during, or whatever injection is there, it should only be present during the chaos injection phase, and not before that, not after that. So these health checks basically help you to know whether there is any spillover or there is spillage after the chaos injection, also whether your pods are not in the running state, or then they haven't still gotten back yet. So that's something that breaks down the hypothesis in basic sense, right? So this probe is going to do that. And then we have an HTTP probe, which is like card service availability. So this probe is basically going to call an endpoint, which is this endpoint here. Okay. And it's going to check whether we are getting a 200 response code or not. So this is basically a API liveness check or API status check. It basically goes and checks whether the API is responding, working properly or not working properly, right? So if I go to this /card endpoint here, I guess I should be able to, yeah. So I can access the card here. Same, this API is going to check whether we are able to access the card or we are not able to access it. Okay. And then we have the website latency check, which is a prompt probe. So if you view the probe details, you can see there's an Prometheus endpoint provided and then a query provided. This query is basically, if you see the Grafana dashboard here, you can see a probe success percentage. Okay. So this query is basically going to like get this front end 80 API latency, like what response time we are getting from this specific endpoint, and it's going to like run it at every second for a 60-second interval here, right? And then it's going to give us that output in seconds. So we just basically want to test out, in milliseconds. So we basically want to test out whether our latency is below 120 seconds or not, right? So like when we are injecting a fault, we want to check before and after the injection of the fault, whether the latency, how soon or how well our services are picking it up again, right? So basically, we want to see after we injected the experiment with the fault, after we have deleted the pod or we have done network latency, we want to see whether after the injection is completed, if our services are back to normal, okay, and the latency goes down below 120, which is our standard, like which fulfills our SLAs or SLOs. So that will basically this probe will give it this output and tell us, right? So this all we can do here in the dashboard as well. But like when we're running these experiments as a pipeline structure, we don't actually want to keep a lookout on latency and everything. We don't want to manually test it out. So these probes are basically going to run during execution and give us a result that whether your experiment passed or whether experiment failed, right? So I went through a lot of details to the probe because these are very important in terms of testing out a hypothesis, which is like the base of doing chaos engineering. If you have a hypothesis and you think you want to simulate something, you need to test it out as well. You need to have some proper results maintained. So you have to get to know whether it's working properly or not, right? So that is something that probes are going to help you out, right? So we'll just get back to target application, and you need to select the namespace and then select the application. So we are injecting this on the card service. So I'll just select app equal to card service. I want all of you to like select this app label here, app equal to card service. And then after doing that, just click on apply changes and click on save. Great. So now the experiment is saved. You can just check it out here also. So this is the experiment we just created. It'll now show up as a list here. This is the earlier experiment we created. You can click on delete experiment and it will just delete it out, right? And you can click on this experiment here. It will open up the editing part of it. You can also edit it, the manifest here directly for the experiment. Great. So I guess everyone is good to go. If anyone had any issue, please put it in the chat as and when I speak and I'm speaking. Cool. Okay, so let's now actually go ahead and run this. A lot of theory, a lot of information that is provided. Now let's just go ahead and run it. Finally, so I'll just click on run. Now it will start the experiment run process. And you can see it actually happening here. You will also see the logs coming up here in the console logs. So basically how the experiment is going to run life cycle is, first it's going to install the kiosk faults. So for this, it is going to pull up the manifest from the kiosk that we provided and just go ahead into your namespace using the kiosk infrastructure you connected, and then it will install those manifest, and you will just basically see kiosk experiment and kiosk engine coming up, right? So I'm actually not sharing the complete screen. Let me do that. One second. Yeah, so if you just go ahead here, if I do kg kubectl get, sorry, write the complete command, kubectl get kiosk experiments in my namespace. So I've got Neelanjan, this namespace here. Yeah, so you can see the experiment has started running. You have the probes detail here. It will show you probe details and probe results here. Then you can click on logs and this will give you access to logs. So this will come up once the experiment has started. It is still setting it up. Meanwhile, I'll just show you this. Yeah, so you can see the pod delete experiment manifesto is installed, which is the install kiosk fault step, right? Yeah, now you can see the logs coming up. So this is basically the experiment is starting and running now. So it can basically executing the probes. Okay, and the probe that we provided to run at the initial phase during the kiosk and everything, right? And if you go to this boutique card here, you can see this annotation, which basically tells like the kiosk injection has started, and you can see the success percentage going down because now since basically front end would not be accessible. If I try to access it, yeah, you can see it's not working. Cannot access anything on the application. This is going down. Front end UPS query per second is going down. We are getting more failed queries. Access duration is also, so you can see this in the metrics as well here. That's basically whatever we had running properly is now all the services have started to fail because none of the endpoints are available because we just failed one card service. Okay, so this is something that we need to will as an when you're talking application, if your card service is failing, your product is completely stopped working. You cannot access anything, right? So with this, your hypothesis that if one of the service fails, the other would still be working fine. Like it, we get to know we get to know by through this experiment that that's not the actual case, right? When one of it failed, when the card service is failing, everything else fails. So this gives you an idea and information into your application that a lot of things are interdependent on the card service, and that is basically making card service as one single point of failure. And if it fails, then the whole application crashes. Should not be the case, but yeah, that's what we're able to see. Now you can see the kiosk experiment has completed run. If you go down to the logs, you can see the kiosk result is available, right? And some of the probes passed, but you can now see that the experiment actually completed, but it failed with some errors because one of the probe that we have provided, it did not pass. That was a HTTP probe. This happened because during the run of the application, the endpoint, the front end endpoint was not available. So the probe basically failed, right? This can happen like because since we had only one replica running for the card service, so when we deleted it, it went down and it took up some time to come up again. Meanwhile, that time service was down. So it will give you this kind of result here. You can see the resiliency score. So this calculated on the number of probes you have defined and number of experiments you are running. So since we have one experiment and 3 probes, and 2 of them passed, 1 of them failed, so we have a 66% resiliency score only. Right. So, great. I guess everyone else had a similar kind of run. You were able to run this experiment, see it in action, you were able to see the graphs, you were able to see it actually not working, the application, right? Did anyone had any issue running the application, running the experiment? Sorry, not application.
Yeah, because for me it's a failing actually. So yeah.
The application is failing, or
The resiliency score is showing 0. Some error is showing there.
Okay, can you share that error?
Yeah. Let me share.
Meanwhile, Neelanjan, if you can check in the experiment pod.
Yeah, is it looks okay? Let me. So, is it visible for you or to able to see?
Okay, are you sharing the screen or something?
Yeah, I already said.
Okay, yeah, I can see it now. Yes, can you click on that experiment? Experiment one. Great. Okay, it failed on install kiosk step itself. Can you click on that step? Login. Can you click on edit experiment once?
Edit experiment.
Yeah, it's right at the top. Click on bot delete 6 yeah. Okay, cool. Did you not select an app label?
I have selected. Not sure now. It's not showing. I don't know.
You can click on the cross button there. We'll see. Click on the cross at the top, like left of the name of the experiment. Yeah. Now click on it again. Yeah. Don't select anything. Okay. Yeah. You need to run it on the card service. Not with. It's not like that. Can you select the card service here once? Yeah, apply changes. Yes. Click on run history, not run. Click on run history above it. Yeah. Click the first run. Yeah. Click on install kiosk again. Yeah. It's saying not found the pod. It did not start the pod. Oh, the pods got deleted because we are not. Okay, can you run it once again? Yeah, please go to edit experiment. Click on edit experiment. Yeah, click on pod delete once again. Yeah, saved it. Yeah, select card service again. Apply.
Apply changes, no?
Yeah, apply changes. Yeah. Can click on do not show. Yeah, now click on install kiosk first.
Oh, what to click? You are telling?
Install kiosk. Yeah, this step. Click on it. Need to see.
But this pod doesn't exist, you're telling, or what?
No, it's actually not reading it. Just give me a minute. Is anyone else having a similar issue, or like it is working fine for everyone else? Like if you can react with a thumbs up, or you can react in the chat if it's working fine for you as well.
Okay, all are running only.
I'm just trying to see if it's a similar issue or it's. Yeah, is it working for everyone else? Can you react? with a thumbs up, or you can write it in the chat that it's working for you. Experiment. It's working for Abhi. Great. Okay, so I'm assuming no one else is having any issue. Okay.
Or any steps I missed actually here to set up?
Sorry.
Any steps am I missed any other steps?
No, it should not be. It's actually not able to find one specific experiment path. I'm just checking whether it has installed or not. Should not happen, no. Not installed. Okay, let's just try to run it once again from the beginning. So click on chaos experiment. Click on new experiment. Yeah. Okay, sorry. Now go to chaos hub from here. Go to chaos hub. Select KCD workshop. Yeah. Click on launch experiment for boutique cardboard bounce. Third one. Yeah. Yeah, just remove the number 1657 and just put in a random number. Or you can just like remove the number that let it go. No, just remove it. It's fine if you remove it also. You can just put it that one. It's fine. Yeah, now select the chaos selection.
Okay, I will go next.
Yeah. Great. Click on bot delete. Yeah. Select the namespace. Select card service. Yeah. Apply changes. Save the experiment. Wait. Click on run. Yeah, okay, now it should work. I guess there was some issue with the name.
Okay.
Wait, yeah, I think it should work. I'll just check. Yeah, the experiment is here, and let's get the pods coming up. Great, yeah, it's going to run now. I will see the results. Can you yeah, can you give me screen sharing back?
Okay.
Great, okay.
Thank you.
Cool, yeah, it should run and you will be able to see this something similar coming up. Okay, great. Then yeah, that is the first experiment that we ran. Okay, I think how much time do we have left?
I think we have about 40 minutes.
Okay, 40 minutes. Great. For 40 or 14?
I think it's 40.
Oh, okay, cool. Cool then. Great. So now we'll just go through all the other experiments also. Won't take a lot of time. We'll just take 15-20 minutes to go through all of them. So if anyone gets stuck at any place, just let me know. We'll try to solve it out for you. Otherwise, you can just follow up here. So great. Now let's run the next experiment. We'll now go with the CPU starvation chaos experiment scenario, which will basically hog our CPU resources and let us see what happens. Okay, so great. So we are right now just targeting the cards app service only. It can define which service or which application inside which microservice you want to target. Our focus is right now on the card service, showing like how it's very cohesively made, it's very interdependent. So one thing fails and everything else also stops working. So yeah, select that, click on launch experiment, then remove this number from here, select your infrastructure, click on next. We'll follow the same process here, selecting the app namespace, and selecting card service here, apply changes, right? And yeah, so this also have some probes, fine. It's very similar to what we just saw. This cards resource status check is going to do the same thing that checking the state of application. Latency check is going to check the latency of the what is the latency status, or how much latency is there inside in the API request, and this is going to check whether the API is working properly, if you're getting a response or not. Okay, so the probes are same. If I go to the tune fault section, you can see certain criteria here, which if I had showed you before for pod CPU hog. So yeah, so these are the tunables available. Right now, it's we are limited the scope for, because we don't need to edit these tunables. It's already set up. But I'll just go through them once to let you know like what they do. So with each experiment, you'll have some experiment specific tunables. Like for this, you have the CPU cores and CPU load, which are basically to tune whatever rule or whatever in chaos injection we are doing, how it's going to happen. So like this has a CPU cores and load. You can provide either of them. So if you provide the CPU cores, then it is going to target that number of CPU cores and subject them to stress. If you provide the load, then it is going to provide how much percentage of CPU you want to stress. So if you provide one CPU core and if you provide 50%, then it will stress one CPU core to 50%. If you provide two, then it will stress both of them, so that the total load is being stressed at 50%, right? So this is how you can define what amount of load you want to give to the experiment, right? So it's not, you can see here what we have provided, but if you go to the YAML, yeah, here you can see that we have provided 100% load on one of the CPUs of the experiment running, right? So that is what we are going to target. And similarly, there are other tunables which are not specific to this experiment, like the target pods container. These are before like available, like these are there for all the experiments. Then you have these two, container runtime and socket part. So these two are required for certain experiment like CPU hog, memory hog, or IO stress, and even for network based experiments, right? So, or container kill. So for the experiment, you need to provide the runtime that your infrastructure is running. So right now we are using a containerd runtime, and you need to provide the socket path. So you can, like, for default it's set to this. For Docker containers, there are different socket path. You can find it on the internet what's the socket path, right? Yeah, and everything else is very similar for this experiment also. So right now we are going to target the app card service and inject 100% load on one of its CPU, right? And the time we have set for the experiment to run is 60 seconds. So with CPU chaos, what happens is like it will start with iterations. It will like linearly try to increase the CPU stress. So if your CPU like has a lot of cores available and you want to target a lot of cores, and then you need to provide a certain chaos solution also, because we cannot have 100% CPU utilization in 1 or 2 seconds. It's going to take up some time, like 15-20 seconds, depending on the core size and depending on how many number of threads can run. Based on that, so basically, like 60 seconds right now for one core getting 100% would be a sufficient time. It will basically go to 100% CPU utilization in probably less than 30 seconds. But yeah, depending on what you want to provide, you can basically change the duration and the value of the CPU load and the number of cores you're targeting. But that needs to be in some relation, because otherwise, whatever you're targeting will not be completely utilized to that percentage. Great. So yeah, that's on. This is the only thing we need to set. Click on apply changes. You can save it, or you can run it directly also. So yeah, let's click on run. Let me just see if I have KTOP available. I don't have KTOP. So I'll just check it out for my card service here. It's installing the application right now. I just want to see if I'm able to show the CPU utilization, whether it goes up or not. You can also see it if you have a KTOP application installed, or if you have a metrics portal, you can see this card service utilization getting up. Okay, so now the application should start. If you're looking into this, into what pods are running, if you're watching them, so you will see this pod CPU hog workflow chart. So this is basically now setting up the experiment, and this is you'll see a runner pod coming up, which then will great. So yeah, so this is our controller pod, and this is our experiment pod, and now we have a helper pod. So helper pods is the concept, like we set up another helper pod here, which basically gets inside this card service, which runs whatever command we want to do inside this card service, and that actually injects this CPU utilization percentage increase. So now we'll see the degradation happening again. So slowly the CPU utilization should come down. And you can see the access duration is going up, which is not what we expect to happen. Which is not what we would want to happen, because the time to access the service is going up, the latency is going up. Then we have the QPS, which you can see slowly going down. For checkout service, it went down completely. For cart, it should also go down in few time. Or maybe it will not be like completely up to the mark. You'll see some kind of failure happening. So the access duration has gone up a lot. The latency is increasing. I'm not able to see the CPU is getting up over here, but it should be going up. Yeah, so the acceleration went up for the card service and for the front-end service. So yeah, so with latency, with that some added CPU pressure, you can see the QPS went down a bit for the card service. The acceleration for front-end and for the card service went up, even for product catalog service also. So meanwhile, like we were targeting the CPU to. So this basically schedules showcase a scenario where you have a service running, and there's a lot of load coming onto your service, right? A lot of users are using it. So these kind of loads you can these kind of loads you can show up, simulate using this service, right? So we'll probably have the probes running now. Yeah, so all of our probes pass. So that means whatever hypothesis criteria we set, that the service needs to be accessible. So it was accessible, and the latency needs to be less than 120 after the injection phase. So that was also there. So this means like the hypothesis that we set up, like if this much amount of loads comes to our service, it should be working properly, and that did happen. So This gives us a complete 100% resiliency score for this specific chaos experiment run. Great. Does anyone have any queries, any questions, or you were able to run this experiment, or if you had any issues? Okay, great. Also, if you were able to run this experiment properly, please give a thumbs up. Please react with a thumbs up, or please write in the chat so that I know that it's working fine for everyone. Everyone is able to uh, run the experiments. Be able to do great. Okay. If it's still running for you, you can still respond to the thumbs up that you are running this experiment right now. Okay, great. I suppose I would assume like it ran fine for everyone. Everyone is able to get 100% resiliency score on this, and it worked fine. Great. Okay, so now we have the decayed network latency experiment. So if we go with this one, you can just select that experiment and delete this. Select the chaos infrastructure, and then that's it. Select the namespace and applicable. Now, if you come to the default, you can see network latency section here and a jitter section here. So this is something that is unique to this experiment, network latency. So in the network latency option, you can set the millisecond of the amount of latency you want to add to the service. If I write 2000 here, then that means a 2-second latency will be added to my service. So this, I would be able to see it here in the actual duration for the card service. I'll see this going up by the value that I provided. The QPS will be going down because it's taking a lot of time to run this, and I'll just keep it to not 2000. I'll just keep it to 500 or probably 600. Okay, and then the jitter is basically the deviation from the latency value provided. So if I provided 100 here, then it will basically inject a latency from the range of 500 to 700. And like, so suppose like for one request, it will add latency for 570 milliseconds. For one, it will add a latency of 630. For one, it will add 680. For 600. So it will randomize between this range from 500 600 between this range, and it will add different latency values to this. It will add some jitter also into this. Okay, you can define whatever network latency you want to add. 600 seems like a good value to me, like since we have defined, or suppose like into it 500 also, and just make the jitter as 200, so to be like 300 to 700. And yeah, so this will give me a good range. It depends on what SLO you want to set up, what is the latency that you want to target. So it depends on that. This value you can finalize based on your use case scenario. But yeah, and other than that, everything is very similar to all the experiments. We have the same 3 probes running here. This time we might expect this latency probe to pass. Okay, let's see, because we're actually adding latency to the service. So it could be whether the website is having some amount of latency over and above the value that we have provided, right? So this is great. So like click on apply changes, click on save. I guess everyone know what's happening now with this experiment. And also I'll go through again how this experiment works. So it's like basically it will generate based on these values because we're targeting this app card service. So inside that pod which we derive through whatever value provided, it will add a network traffic rule, traffic control rule, which will basically tell it to add 500 milliseconds of latency with a jitter value of 200 to all the requests that are outgoing or incoming to this specific pod, right? But there is one more thing available with this experiment, that we can tune it to work it for specific IPs or hosts only, right? So how can we do it? We have these two variables of these two tunables called destination IP and destination host, which is common to all the network level experiments. So what we can do is we can provide either of them. If I want to target one specific IP, supposedly I just want to like affect the connection between my card service and checkout service. So I can just provide the IP of my checkout service. So only the connection, only the network between the card service and card outgoing and incoming to the card service from or to the checkout service will be affected. Everything else would be working fine. So I can fine tune it to work for one specific service or one specific IP as well as one specific host. So if I'm targeting some kind of third-party application, if my service calls some kind of third-party APIs, and I want to see what happens when those third-party APIs are not working properly or they're having some kind of latency, so I can add use this experiment, use this fault, and then add the host name or the IP, whichever I have for that third-party application or for my internal application, and then fine-tune it. Right. So this is something that comes with all the network level experiment, corruption, duplication, loss, partition, right? That's there. You can utilize, and also you can define the network interface. So like if you have multiple network interfaces which are like one is connected to providing you internet, one is providing you connection to other services, you can define that network interface also to like so using these network interface, pods, destination IP, you can tune to what extent you want this network latency or network loss to occur. Okay. I hope that was clear. I hope it resolve like how this application actually works. This experiment actually works. Okay. Is anyone trying to speak up or any questions? Girish. Okay, cool. So yeah, that's about network latency. I'll click on run. So I'm going to install this app experiment. So if you go, just I showed you up in the initial phase. If I do kubectl get chaos experiment, so it will show up all the experiments or all the faults that are there, right? So this is the first step that it does, and then moving on, we'll see. Yeah, so now the base code is there. Okay, the first step is complete. So these are the steps for whichever steps are there will come up. And now step 2 board is starting out. We'll see this coming up. Yeah, so you can see your configurations inside this runtime. Also, you can see what values are provided to validate. You can see what probes you are running, and then it also gives you a probe summary here, which is basically what is the status of a probe, whether after the complete execution completes for your probe for whatever mode you have provided, it will show you why the probe, like if it passed, then it passed. If it failed, then why did it fail, right? And with the error message or anything that's available, that any information about the probe is available, it will show up here. So we can see now that the chaos injection has started. We'll see some latency getting added. Yeah, the probe success is going down because the latency is basically where we were checking for the latency, and since it's the API stopped working, we'll see that. We can also show it to you here. Yeah, so you can see it's taking some more amount of time as compared to what's happening before. You can see the queue pace is going down and the acceleration is also going up Slowly it went up. It's going still 305 seconds. For card services, actually, it's going up 420 seconds. So yeah, so like with the latency is going to fluctuate between the values that we provided from 300 to 700. So we'll see some kind of it happening here because it's the randomization might be there to some extent. Yeah, so see, other services with the latency thing are not affected vastly, but yeah, we can see for front end and for the card service, the increase in latency is way too much. So previously it was like 9 seconds, 10 seconds. Now it has gone all the way up to 400 seconds right here. Okay, now I guess application would have application run is completed. Most probably, yeah. That is why now you can see this coming down, and probably this service is working properly again. Yeah. So you can see like this is much faster as what it was when we injected the chaos. So you can see the acceleration, the latency for card service coming down, the QPS for front end going up. Card QPS also went down a bit, not much, but yeah, you can see it rising up again. Great. Okay, so now one of our probe failed. It will just show up the results of the probe here. I can see the summary. Okay, so the card resource status check passed because the application running was fine. The card service availability was also working fine because we would also able to see like the application was working. We were able to access it, but the latency probe failed because we had added and latency which was over and above the expected latency, and we just had one pod and we targeted it, so the latency was over 120 seconds. We can see like this was greater than less than or equal to that value, so that's greater than and equal to that value, so that's why it failed. So yeah, so this gives us again a 66% resiliency score because one of the probe failed. So this tells us that like our hypothesis like after some certain issues, it should come back to the normal. The latency should not be there, but it was there. So our application is not ready to handle such kind of scenario right now. So great. That was all the 3 experiments that we ran. And we now have the final multi-fault experiment, which is basically all of those experiments running parallelly. So we'll see everything happening. We'll see the pod getting deleted. We'll see latency getting added. We'll see CPU hog to be injected on whichever pod is available there. Right. So that we will be able to see it. So before we run that, I just want to ask like if anyone's having any kind of issue with running this experiment, or everyone was able to run it properly. Or whether if I'm going too fast, or you want some, if you want me to go a bit slow or anything, or if I'm going too slow, you want me to go a bit faster than that also.
By the way, a quick time check. We have about 15 minutes roughly.
Got it. Cool. Then great. Then let me just launch this experiment here. You can select the multi-fault experiment. So yeah, you can see all of them are going to run in parallel. I would have to go out and select my application for these services. So for CPU hog, I'm going to, okay. So sorry, one mistake from my end. It's actually not the 3 experiment that we just ran. These are resource hogging experiments, the CPU hog, memory hog, and the IO state experiment. So the CPU hog is going to hog the CPU memory. Memory hog, as we didn't run this experiment, this is going to hog the memory, and IO state is going to increase the IO uses, input output uses of the specific pod by doing some read and write operations to an extent. So this is going to show us like what happens when our service or application is under a lot of load, under a lot of stress. Are we scaling up? Are we scaling it up to handle? Do we have some proper scaling up service available? How much time it takes to scale up? Is it do we need is it proper enough? Is it working enough? Or is the application able to handle that stress or not? Right. So this is the fourth scenario, right? Okay, so CPU hog we already went through. Pod memory hog, you can also see we have this memory consumption variable here, which is basically providing how much memory you want to consume in terms of MB, in terms of megabytes. And you can provide this here. This also have one more option available where you can define the percentage also. If you go to pod memory hog, you'll see memory consumption is there, and number of workers is there. So basically the higher number of workers you provide, the faster the memory consumption value will be utilized, but that will also use more number of CPU threads to do that. So you can define it how fast you want the memory to go to rise up. If you want it to rise very fast, if you want it to rise slowly, you can define the number of workers accordingly. Right now, I guess it will set to 1. And here we only have the one probe only, which is going to do the health check before and after. With the CPU hog also, we have one probe only. And with IO stress also, we would have one probe only, which is going to do this. And yeah, with IO stress, you can provide the percentage or the bytes also, how many bytes you want to utilize. I'll just form that. Yeah, you can provide the bytes also, how much bytes you want to utilize or how much percentage. If you provide a percentage, then it will take that. And if you want to provide bytes, then you should not provide any value to the percentage, right? And yeah, that's it. And then you have a volume mount path variable also, where you can define where you want to which volume mount you want to inject this IO stress chaos into. Right, so this gives you a good fine-tuning options, like how you want this experiment to run and happen, right? So yeah, that's how this whole. So these are the category of stress experiments that harness chaos engineering provides, right? So great. I'll also go through one more thing here. There are scheduled options, so you can actually schedule experiments to run at specific intervals that you want to do. So if I just provide it to run every 1 hour, so this will basically run every hour. If I wanted to run it every 12 hours, I can provide it to run daily at this specific time, weekly on the day and time, monthly, yearly also. So you can create your own pipelines of your experiments, and then you can set them to run. This will basically run and give out a result. So you can have these running, at midnight time, and you can see how your services are still performing under duress and under your situation, and you can keep testing the hypothesis every day or every week as per your requirement. And once you go to this chaos experiment section, this overview section, you can see number of experiment you are running, right? And your recent runs here. They would also be coming up a dashboard where you can see your pass and success percentages, and like how your total experiment runs are, and how much are passing, how much are failing. So this will give you an idea of how your application is performing under the situation you provided. So right now we'll be running an ongoing experiment, but this is one more option that you get. Great. So now after setting these up, the app labels and everything, you can just click on run. And now this is going to wreak havoc into the application by doing all kind of steps possible, input, output, memory, and CPU. It will take up around 2-3 minutes to get completed, and then we will be done with this demo. Here we'll just see them coming up here. We can see what's the status of our services here. So like kubetest is at 150. The latency is very down to 20-22 milliseconds. Probe is working properly. Each of the services we don't see a lot of latency. Everything is working quite fine. Right. So now, okay, now it will get started. So you'll see the pods coming up here if you are watching them. So you'll see CP hog initial probes are there. So these probes are going to check run. So we are using some source probe here. I just mentioned like you can use source command probes to run your own specific tools helper you want to. Now we have the IO memory CPU helper running. So all of the experiments have started running. You'll see the load coming up here. And slowly as the memory CPU utilization, IO utilization rises, the service, let's see how the service is getting affected. Right now, I guess it's working fine. Okay, so card service, you can see the actual duration is spiking up. Our front-end service also acceleration is spiking up. We still seeing 100% probe success. Like the service is accessible, but it's getting a bit slow and slow by that, slowly. So as I mentioned before, also like it takes some time, it takes some amount of time for whatever values are provided for the hog, CPU hog, and memory hog to actually get to those values. If you provide a longer duration, if you provide like 180 seconds, 300 seconds, then you will see them going a lot more up as the complete CPU and the resources are getting hog. If you provide a smaller value, then it will like go till a point and then experiment will stop. So it all depends on like how much time and how many workers you are giving that fault to actually increase the CPU and the load. This is for the resource intensive resource hogging for something. Great. So I think the experiment has completed most probably. Yeah, the helper have gone. So experiment is completed. This means now the QPS and everything is going to go up again and the acceleration going to go down. You can see it here. Yeah. So during that time, the service got slowed, went from 7 milliseconds to directly it went up to 62 milliseconds. It went this at front end went up from 20 milliseconds to 40 milliseconds, so double on that front. This card service for injecting, this also got affected a lot. So we were able to see some amount of increment, I guess. It went down also. I guess this was not accessible. That is why we are not able to access this. That can be that reason. But yeah. So great. This experiment, I guess, has completed runtime. We will be seeing the probe results. I probably think the probes would pass because we were just validating whether the application that we're running is still working even before and after this experiment run. So if you had provided higher values for the memory or CPU, the probe would have the pod might have get evicted, and it would take up some time for it to come up back again, and then this probe might have. That we wanted to show you how you can have different faults into experiment. You can have multiple faults into one experiment. How you can create a hypothesis. How you can check it out using probes. How you can run experiment, watch them running, and how you can also monitor them. Right. So yeah, that was it. From the demo and side of view. If you have any questions, please shoot them up. I guess, or we will just go ahead and give you a overview of the architecture, how things are working inside. Neelanjan is here, he can take this up. Meanwhile, if you have any queries, shoot them in the chat and I'll try to answer them.
Thank you so much, Akash. I guess we can take the questions first. We can discuss the architecture briefly otherwise. Guys, so we are at the almost at the end of this workshop. If you guys have any questions related to the workshop itself or related to harness chaos engineering or litmus chaos or just chaos engineering, please feel free to ask them. Otherwise, I'll just do a brief dive into the architecture of litmus chaos.
Yeah, one more thing. So inside the guide that we just provided, you will see a point to join the Harness Community Slack workshop. So you can do that, and you can post up your queries. If you have any issues running any experiment, you can post it up there, and people from Harness, people from the community would be happy to help you out. I've shared the link in the chat also. You can use that to join. And if you have any questions or queries, you can just post it out there, and a lot of people will be there from the community to help you out.
So just one question here. You means you have a web application and means the browser application you simulated. If we have some other means application, actually, how difficult or how it is easy to do actually?
So it's very similar to how we just did right now. The boutique card service, service that we just showed, it's like a basic e-commerce application. If you have a application running on Kubernetes, the process is very similar. Just how we are selecting the namespace and we are selecting the app label that is there. So you can utilize that same process to select your own application and that inject the similar kiosk faults into them. Or else you have a like I shared the documentation also, the number of kiosk fault that Harness kiosk engineering offers. So you can have any you can select any of those kiosk faults according to your use case, and then inject them. So it's very similar if you have Kubernetes. Even if we have non-Kubernetes based application running, we also have support for those as well. So you can see for AWS, if you're running your services on AWS EC2 instance, ECS instance, or AWS Lambda services, or probably GCP, GCP compute instances, or VMware. You're running a VMware instance and you want to inject yours on that. So you can utilize those experiments as well to inject it on non-Kubernetes. But yeah, for any application running on Kubernetes, this process is very similar to what I just showed. Any application you're running. I guess that answered your query.
Yeah, some bit. Yeah, I need to understand a little more. Yeah, but yeah.
All right. So we have less than 5 minutes left. Would you like to wrap up right now, Akash and Neelanjan?
Sure. I guess we had just one last question regarding the architecture, so I won't take more than, let's say, 2 minutes. Let me just quickly share my screen and show you the architecture. So I'm just showing you the Litmus Chaos architecture right now, but since Harness Chaos Engineering builds upon Litmus Chaos and it just uses its open core, so it's the same thing that is getting used in the Harness Chaos Engineering as well, more or less. So the entire architecture of Harness Chaos Engineering or Litmus Chaos is split into two parts. First is the chaos control plane and second is the execution plane. The chaos control plane is the user facing component of the Litmus Chaos that enables users to interact with the Litmus Chaos platform. It enables you to create the different experiments, manage them, edit them, and execute them as part of CI/CD, so on and so forth. So as part of this, you have different components such as, for example, the chaos center logical equivalent. This can be the UI that you're viewing, for example, or this can be the API integration through which you are directly speaking to this server. It's nothing but a GraphQL server to which all your requests go, which is also using a Mongo database as well as an authentication server in order to facilitate authentication as well as store the various information related to the experiment execution. But what is more important is this GraphQL server is essentially speaking to your chaos execution plane as well. Now, inside the chaos execution plane, you have the Litmus agent infra, what we call the chaos infrastructure here. You just install the chaos infrastructure within your Kubernetes application. So that means that this entire chaos execution plane therefore resides within your Kubernetes cluster to aid with the execution of chaos experiments within your target infrastructure. So this entire chaos control plane can be understood as the HC SaaS deployed. I mean, it's SaaS deployed, hence you don't need to deploy this. It's already there for you. You just need to set up this chaos execution plane within your Kubernetes cluster and get started. Now, as I had already spoken in the earlier that we use Kubernetes custom resources in order to make these experiments run. So if we zoom in it a bit, we can see that we have something known as chaos workflow custom resource, which is kind of the experiment custom resource that Akash was showing you in the form of the manifest that we create. Now that contains different other custom resources such as the chaos experiment custom resource and the chaos engine custom resource, which are the building blocks of every chaos experiments. So each fault will contain a chaos experiment custom resource and a chaos engine custom resource, which are then reconciled by the chaos operator, which is the central component in this entire chaos orchestration. So if you know the operator framework, an operator sees custom resources and then reconciles the current Kubernetes state to match with the defined state. So we kind of therefore execute the experiment as part of this reconciliation by creating experiment jobs and executing the experiment. So that's a high level overview of how basically it runs. You can just go to this page. I've already shared you the link, and therefore read it in much more detail. We definitely define it in much more detail that how exactly we execute these experiments. So yeah, I guess that's a wrap for the workshop. I hope you learned the basics of chaos engineering today. You saw that how easy it is to get started with harness chaos engineering and how you can get started with creating your own custom experiments using harness chaos engineering. So yeah, that's a wrap from us. Thank you so much.
Thanks a lot, Neelanjan. And huge thank you to both Neelanjan and Akash for hosting the session on a Saturday afternoon. It was great to learn about chaos engineering from both of you. And also a huge thank you to everyone who attended the workshop. You also set aside like a good 4 hours on your Saturday to learn. And I do have one request for the participants. I'm going to be dropping a feedback form. Please do fill it out. And also, if you haven't already registered for the physical event, you can buy the tickets at tickets.kcdplr.com. I'm going to drop the link for that as well in the chat. And yep, thanks a lot once again to everyone. Hope to see you in the next virtual workshop. I think that's next Saturday. I think we also have one later today.